Hello, welcome to Data Science course. We're going to start with the introduction. About me, you can find a lot about me on my website, about what I'm doing, about my work, about my Udemy channel, my portfolio, and you can contact me through here. If you want more information, you can always go to my LinkedIn profile and look what I'm up to, where I've been working, and all information about it. I have more than 15 years of experience doing development, and now I'm trying to make a video on data science based on all the things that I've learned. In this particular course, we'll cover much more than what I've included today, but it will keep on growing as and when time goes forward. We'll start with simple installation of Python, the IDEs, learning about Python basics, learning more about NumPy, the basics of NumPy, pandas, and matplotlib, learn about different types of regression and decision tree, and much more going forward. We'll also cover some of the real life examples of where data science is used and how you can become a data scientist through this course. Welcome to data science class, and in this one we're going to look at prerequisites and resources. Hi, I'm Vivian Arana. So what prerequisites do you need to start this course? Actually, you don't need anything. Having a little bit basics on fundamentals of programming will help. We will be learning Python programming language from scratch, so you can just follow along, or if you need some more understanding, you can always pick up some course on programming or fundamentals of programming and get back to this course. But we will be starting from scratch on Python, and we'll be looking at some of the libraries that are available in Python. So we will go over everything in this particular course. Resources. So whatever projects that we do in this course, they will be available on GitHub. So you can go to my GitHub, and the link is available in this description of this video. So you can go to, if you go to my repository in my GitHub, you can look for repositories, and inside repositories you'll find a repository named as data science, and this is where we have all our Python files that we'll be using for this particular course. I'm going to keep on adding more and more courses or more and more videos, so it will keep on growing. So if you find something new, it will be available on YouTube soon. Thank you for watching. Hello, welcome to data science classes. Today we will cover how to install Python and different IDEs, and depending on what you like, you can pick and choose. There's a bunch of different options available since Python has been around for a long time, and this is one of the favorite languages right now other than R. So let's look at what options do you have. So first, try to check if you have Python already installed on your computer by going to your command prompt and type Python. If it gives you a prompt, it will tell you what version it is, and that means you do have Python installed. So you don't have to install, but if you want to update to the latest one, you can do that. You can exit out of this prompt. The way to install Python is from their website. This is one way of doing it. Some of the IDEs that we might need is Jupyter. This is one of the commonly used, widely used IDE, and we will be using this for our understanding Python tutorial. Another IDE which is used quite a lot is PyCharm. You can download it from JetBrains. This is the website for them. You can just say Google for PyCharm and you'll find it there. Another quick option is repl.it. What I do this, when I use it, is mostly to do some quick tests. You can say that I want to create REPL for Python language. It supports a lot of different languages. Just to test some things out, you can quickly write a few lines of code and see it work just like this. Let's say I'm gonna make hello. You don't have to understand anything right now because we will go over all these things soon. Print A, and you'll see the console comes right next to it and it will print out. So this is used for quick snippets if you want to run it and see how it works. So that's one option. Another common distribution tool is Anaconda. This is not an IDE, but it gives you all the different IDEs, Python, all the libraries that you might need in one single location. So this is a one-stop shop for everything that you need for starting up with data science or any programming language for data science. So let me download this. I'm going to go to the download link, click on it, and I'm going to say download. I'm using Mac, so it's going to automatically give me a Mac OS installer, but you can install on your Linux or Windows machines by clicking here, or it will automatically take you there when you open this page on that particular machine. I'm going to go and download 3.7, the latest version. It's going to say allow downloads, and it's downloading. It's going to take a little bit time because it's pretty huge file. So as you can see, it's 442 MB. So it's going to take some time to install. So we'll pause it here and come back once it's done downloading. So once it's completed downloading, you can click on the package file that comes along with and go through the instructions. Continue. There'll be a bunch of items. You'll have to agree to some licenses and enter your password to install this software. As you can see, it will also install PyCharm IDE for you. So if you want that, it will ask you an option. So installation is complete. Now it's asking for PyCharm. So I can say continue, install everything, and summary. It will give you a summary of everything that has been installed. I'll close it and I'll move the installer to trash. I don't need this anymore. Once I have that, you can directly open Anaconda Navigator. That's what will be installed. I like to move all my editor tools right up here, so I'm going to move this here. It might take a little bit time to open this up the first time, but once it opens up, it's going to ask you, do you want to update? So it looks like there's an update after we installed. I'm going to say don't show again, and it shows me that it has Jupyter Lab installed, which I can launch. It has Python Jupyter Notebooks installed, which we'll be using. It has Qt Console, it has Spider installed, and these are some other tools which are available for installation, but they have not installed. So I use Visual Studio Code for some other languages while writing C#, but it can be used for Python. There's RStudio available if you're interested in R, which will be part of some of our next tutorials going forward. But this is how you can start. I can go and launch Jupyter Notebook directly from here. It will open up in terminal and launch Jupyter Terminal. If you don't want to open using Anaconda, what you can do is I'm going to close this. You can go to your terminal and just type Jupyter Notebook, and it will open up directly from your terminal. And you can go here, you can create a new, it will show you all your folders and everything. Is running on your local host, so it's a browser based editor. So I'm going to just say Python 3. If you had more programming languages, when you said Niv here, it will probably show you R and Python 3, but I just have Python 3 installed, so it's going to show me Python 3. And this is your editor. This is the IDE that we'll be using going forward, and you can go through all the different options, but we will look at them as and when we code. It's best to learn them when you're using it than to learn it beforehand. Sometimes some people like to look at it beforehand, like if you want to look at keyboard shortcuts, because you would want to be not using your mouse all the time and run keyboard shortcuts. So it's a good idea to look at some of the things like how to create headings, how to create a raw cell versus a markdown cell, how to move up and down, how to get out of the edit mode. So these are some of the options that are available. I would like you to go through them once just to get an idea of it. You have different widgets available. Kernel is the one that actually executes your commands. Each one of these items is called a cell, and these are the cells. You can run your code, write your code here and run cells. You can insert cells, delete cells. There's a lot of different options available, and this is pretty much your IDE which we'll be using going forward. Always make sure you save your notebooks just so that it is available. It will save it as untitled and keep it saving as in when you press save or Command S or Control S, and it will be available for you. All these shortcuts are available. Go through that, but we'll be starting coding in Python from the next video. Welcome to Data Science class. I am Vivin Arana. Today we will look at Python basics. So let's start with opening up a Jupyter notebook. First, we have already installed everything that we need in the previous video. So let's go and open Jupyter notebook. If you have not installed yet, I'd say go back to the previous video and start installing. I'm going to go to my documents folder. I have created a folder called as Python files, and this is where I will save all my files. It's good to organize your files at a particular place so you can go back to them later. I'm going to go here and I'm going to start a new Python 3 project. I'm going to call it first project. Great. Since we're not going to do much in this one, I'm going to just go over some of the things that we need. Now you can, whenever this cell is green, that means it's active. So I can go ahead and do things like print hello world. And if you want to run it, you can run it using this, or you can run it using shift enter. That's some of the shortcuts that are available. If a cell is blue, that means it's not active. You can press enter to activate it. If you want to remove it from the activation mode, just escape. If you press F, it will start finding stuff, searching stuff for you when it's in unedited mode or in not the editing mode. Other things that you can do is some of the things available in your shortcuts here. What I want to learn is how do I add comments, or how do I add headers. So what you can do is you can escape, press 1, and this will create header 1. If you want it header 2 is what you type, 3, 4, 5. So depending on what you want, you can probably look at keyboard shortcuts here about the headers that are available. You can also have markdown language, which with M. So I can go back to my cell, remove everything, escape, and press M. This will remove the line, code line, and it will treat it as a markdown language. So how do you type something? So I can say, let's close this. I can say this is a header with markdown. So I'm gonna say **, which is for capital cell. Enter. Shift enter. So go to the next line and it will appear as a header cell and not as a line of code. So this is how you can add all different things to your notebook. Now going forward, we will look at dive deep into coding and how do we understand Python and all these different things available to us. So get ready and open up your notebook. Welcome back to Data Science. Hi, Vivian here, and today we will look at Python comments. So let's go back to our notebook and create a new Python 3 notebook. I'm going to want to learn more about comments. Comments kind of help in documentation, or also for other to understand how or what you're actually doing inside the code. I try to add comments everywhere around my code, just so that when I come back to it, I understand what I was doing or what I was thinking before. So for example, if I want to do a class on comments, I can say Python comments. If you see, everything is kind of italics and in a different font than regular fonts. You can add multiple lines of comments. Sometimes some people like to make it more decorative, like this. This is my code, compound. Can add as many as you want, front and back. That's how it works, and have these comments available. It's not much useful in our Python Jupyter notebook, but it might be helpful if you're using a different editor. For example, here I can say this is my code where I print hello world, and below it I can print hello world, and I can say this is the end of my code where I print. So you can add comments just to give yourself a good understanding, and there are some tools available which will actually go through your comments and add documentation automatically. So it helps in the long run to add comments to your code, even for you to understand, others to understand, and also if you want to kind of make sure that it is well documented in future. So that's how you can use Python comments. Hi, welcome back to data science class. I'm Vivian Arana. We're going to look at Python variables in this particular video. Variables are nothing but a temporary storage where you can store some values which you can use throughout your code. In most of the programming languages, like let's say JavaScript, if you use JavaScript, you have defined variable by a keyword var. But in Python, you don't have to actually specify anything. You can directly create a variable and start using it. What do I mean by that? Let's go ahead and start creating variable. So first, let me create a notebook. Inside this notebook, I'll create a variable a and assign a value to it 5. I can create another variable b, assign a value 4. Run that. Now, if I want to print this value, I can just say a and have the value displayed outside, b, enter, and I have the value of b displayed. It's called variable because the value can keep on changing. You can assign some different value as and when you go. I can say b equal to 7, and when you print out b, you'll see the value of b is 7. I can also change the type of the value that I'm giving, say string, and if I try to display it, you'll see it changed to string. So you can create variable and keep on changing its name. As the name says, it's a variable, so it means it can change throughout your code, and you can use it to do different things. Like, it's more like, what's your name? Your name is, let's say, Vivian. Your name is John. So you can keep on changing it depending on who you're interacting with. Your age can constantly change every year. If it doesn't, there's probably something wrong, but that's a variable. Your age is a variable. Depending on which year I ask you, your age will be different. So that's how variables work in code. Hi, welcome to data science. This is Vivian here. Today we are going to look at different Python data types. Now, we have already worked with variables, and variables have some values, which is also called as data, and they belong to a particular type. There are basically 5 different data types that are available, which are integer, float, boolean, complex, and strings. So let's look at some of them in our examples. So let's create a new Python notebook. And if you can see, these Python notebooks are stored in .ipynb files. If you ever see these files anywhere, that means that you can open them in your Python notebook. So I can go here. Now, what are the different data types I mentioned? First one is integers. Let's look at them. So if I say a equal to 5, this is an integer data type. I can always say type of a, and it will tell me what type of data type it carries, which is number 5 is an integer. So that's why it's saying the type of a is 5. If I changed a to, let's say, hello world, and now say type of a, it will tell me that it's of the type string. So this is how you define strings, by using double quotes or single quotes. There's also something for triple quotes, but we'll look at that later. So we saw integer, we saw string. Floats are usually defined by a decimal point. For example, 3.56 is a type float. So if I display this here, you'll see that it's a float type. Other than that, I mentioned that there is a data type called as boolean, which is true or false values. So I can say true. Type of C is boolean. So this carries only 2 values, either true or false, and they are defined as something like this, true or false. You can display them out. And the last one that we have is something called as complex. This you probably have seen or might not seen it. It's usually is divided into a real and an imaginary value. For example, 3 plus 6j, where 3 is the real part and 6 is an imaginary part. You probably, if you have seen it in some other languages or somewhere else, you probably have seen 3 plus ji, which I stand for imaginary, but here we use j in Python. And if I say type of d, it will say complex. So this is a complex type of a variable. So we have different types, as you see here: integer, float, string, boolean, and complex. So these are different data types that are available in Python. Hi, welcome to data science class. This is Vivian here. Today we will look at Python strings and what are the different functions that are built in with strings in Python. So let's go to our notebooks, create a new notebook. I'm gonna save it as Python strings. Let's look at how we can declare strings in variables. We've probably seen some things before where I can create a string inside a variable like this and display it out. I can also give it in single strings, single quotes, something like this, single string. And I can also use something called as triple quotes. Triple quotes kind of keep the formatting intact, so I can say triple string equal to, so if you want to keep your formatting consistent in multiple lines with tabs and all those things, you can do this. I can say test with, oops, let's go back, can use some spacing here, triple quotes. There you go. Now when I try to print this out, you'll see that okay, this one was not run, so I'm going to run that again, and there you go. You see it shows up all the spaces, the slash n which is for the next line, and it keeps the formatting intact as and how you declared it. So that's the best part about using triple quotes. You can use single quotes, double quotes, and triple quotes for this. Now what if you want to get the location of a particular string, or what exactly exists at a particular location in a string? So you can use indexing for that. For example, let's say I create a string called as something awesome is going to happen today, and now if I want the location, let's say at 0, at items at index 0, I can do this and it will give me s as index 0. So what happens is a string is nothing but a list of characters. So you can say this is at the first index, second index, third index, fourth index. You can get anything that you want at a particular index, for example index 3, and I get e is at 0, 1, 2, 3, and e is what is available. We can also go the other way around, so it starts at 0, but if you go the reverse way, starts at -1 from behind. So I can say okay, what is at -1, and it will give me y, which is this thing. If I say I want at index, let's say 12, I'll get h, which is this one. So if you say -1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 is h, so it will give you that. You can also get a range, so I can say what is at, let's give me everything from 0 to 6, and you'll see it will say from 0 to 6 is summed. I can say give me everything from 0 to end of line, and it will give me everything if you don't say anything. If I say from start to 7, it will give you 7 characters. You can say that I want everything after 12 to 17, and it will say isum is at that particular character. So this is how you can get the substring by using this particular characters. You can also find the length of a string by just using len function. So this is how you call functions. We've used print functions before, so similarly I can just use the len function and give it a string argument, and it will give me the length of that entire string. I can convert the string into all lowercase by calling the lower function and giving the string as function as an object over there, and say give how does it look when it converted into lowercase, and this is how you can get lower. Similarly, you can convert everything to upper by calling the upper function. So this is how lowercase and upper function work. You can do something like replace items in the string by saying I want to replace I wherever there is I with 0. can do this, and if you see something became something 0 ng and is became o0s going became, so you can convert all these items using replace item. So you can replace part of the string, or you can replace everything in the string, or a particular word in the string using that. For example, I can say I want to replace is, and if you see is replaced by 0 here. So you can kind of do a lot of creative stuff using this. You can also get counts of how many times, let's say, a particular string exists or a character exists. If I say s, it will say 2 times, which is at s here and here. So that's how it can give me count s here and s here. It's not counting s because that is capital, so not the first one inside a string, the string which is something awesome is. So s is here, s is here, so it's going to count these two s's as number 2. And what else? If I want to find a particular item, so I can say find, say awesome. It will find exactly what index awesome is at. You can change it to going. You'll see it will say at 21. So this is index 21, and that's where going is. You can split a string. So for example, let's say our string is currently this, but I can happen awesome today, and now I can say the string dot split, call the split function, and I want to use awesome and split the string. So what this will do is it will give me a list of items where it'll say first item is something, and since it's splitting by awesome, it is going to happen is the second item because there's awesome again, and today here. Usually it's used for, let's say you have something separated by comma, or you have something separated by pipe, and you want to split it based on that. That's where it is quite helpful. So these are different types of ways in which you can use strings and use their functions. Play around with them and let me know if you have any questions. Welcome to data science class. This is Vivin here, and today we will talk about Python tokens, which mostly consists of all the programming that we do. They include keywords, identifiers, literals, operators. We have already seen variables. So how is it different, or what are these things? Keywords are some special characters. Identifiers are special names like variable names and function names that you use. Literals are the values that you assign to these variables, and operators are your addition operation, your multiplication, division, subtraction, logical operators, your relational operators, less than, greater than. So let's look at all these in this particular class. So let's go back and start a new project or a new notebook, and inside this, let's see, how do you know what are keywords? So every time you write something, let's say if I write a, it's not a keyword, but what if I write false? See, it turns to green. Anything that is a particular keyword will change color. For example, class, or if you use, let's say, def, which is used for functions, which we'll see later, or let's say print, it's a function that exists, so it's built-in functions, built-in keywords. So these you can't use it for your variables. They are only specific for your project. What if you try to use it? If I let's say def equal to 34 and run it, it will say sorry, invalid syntax, so you can't use this. So that's what it will tell you. Now let's move on to identifiers. So identifiers are, for example, this. Let's take an example of a variable. A is an identifier which identifies a value of 34. So it's a variable and specifically an identifier. I can use anything like, let's say, underscore album rating as an identifier. I can add numbers inside here, but one thing that you have to remember is they can't start with a number. If you see, as soon as I type a number in the front, it will give me an error saying invalid syntax. So you can not use any special characters or numbers to start identifiers. The only thing that you can use is underscore, or you can use any character to start a particular identifier. And one more thing that you have to remember about identifiers is two variables, for example, some variable equal to 4 and some variable equal to 5. These are not the same things. Identifiers are case sensitive, so if you are using different case, for example here some variable is 4 whereas some variable is 5. So Python interpreter, what it does is it kind of thinks of these as two different. So make sure you don't do a lot of common mistakes that we do is we try to give a particular name and then we forget about the case sensitivity and we use something else and it gives me error and we try to figure out for a long time why is it causing this problem. So be careful with this type of sensitivity, especially to case. So make sure this is right. So this was our identifiers, keywords, and literals. In this case is the value that is assigned to anything, even if it's string, let's say some string equal to string. So whatever comes on the right hand side of our literals, they are constants, they are values, so they can't be changed once you use them, but the variables can be changed. So these are literals. Now let's go to the next topic, which is operators. So I'm going to do is I'm going to save this as Python tokens. The only thing that I'm not adding to this is operators. You can say save and close, and I'm going to create a new one because operators is a big item in itself. So I'm going to say a equal to 2, b equal to, let's say, 6. Run it. Next I want to see the value of a and b. So a is 2, b is 6. Next thing, what are the different operators that are available, or arithmetic operators in this case? I'm going to give arithmetic operators. So arithmetic operators include addition. So I can say a plus b. I have a minus b, a multiplied by b, and a divided by b. So these are different arithmetic operators that are available to us: addition, subtraction, multiplication, and division. So you don't have to do anything special, it comes with it. The next type is relational operators. Create relational operators. In relational operators you have greater than, less than, not equal to, and equal to. For example, I can say is a greater than b, it will say give true or false. So in this case it's false because a is 2 and b is 6, so a is not greater than b. Is a less than b? Yes it is. So true is what we see here. Is a equal to b? It's not, so it's going to give me false. Is a not equal to b? And it will give me true because a and b are two different values. So that's how you can use relational operators. The next one is logical operators. Now there are two different types of logical operators. One is and the other one is or. So what do I mean by that? So let's say a is true and b is false. So they are mostly used for Boolean operations. So if I say a or is used by pipe and b, so a or b. So is a or b true? So when I run this, it will say true. The reason is because one of them is true. When you say a and b, it's looking for both of them to be true, but since one is false, it will say false. Is a or a? So is one of them true? Yes it is. B or b, since both are false, it will give me false. Similarly for a and a, true because both of them are true, left hand side and right hand side. B and b, since both are false, it will say false. So this is how logical operators work. So we've learned what are different operators, that is arithmetic operators for doing addition, subtraction, division, multiplication, relational operations which tell you less than, greater than, equal to or not equal to, and logical operators or and. So if you have any questions, let me know in the comments. Hi, welcome to Data Science. This is Vivian Arana, and today we will look at different data structures available in Python. Now there are four basic data structures that are available. Now these are not variables or data types, these are data structures which actually hold other data types inside it. For example, lists are nothing but a list of items inside a particular structure. Similarly, we have tuples, we have dictionaries and set, and we'll go over each of them in our particular course. So let's start with list. And as I mentioned, you probably are familiar with lists, or if you've done any other programming, or if you probably have heard of arrays, they are nothing but the same thing. So let's go to our notebook and create a new Python 3. Now how do I create a list? Very easy, just use square brackets. Now lists are ordered collection of elements, which means they are in a particular order and they exist in that particular order if you want to display them or look at them. They are mutable, which means you can change the location, change the items inside it from one item to another. It's more like variables, you can kind of change it after you assign it. So I'm going to give a number here. You can have a collection of items, which means you can have a string inside it, you can have a float inside, you can even have a complex number, and you can have a boolean value. So I put each and every one inside it, and if I display it, you'll probably see. And what is the type? If I say type of A, it will show me, it will tell me it's a list. Now if I want to get a particular item in the list, you can always say A of 1, and it will say 1. The first location always starts with 0, so second one is 1, so that's why it says my string is at that particular location. Similarly, as we saw before, you can always go in reverse order. It will give, this is -1 and this is -2, so it will give me the complex number available over there. You can also see some of the items. For example, I can say give me everything after the second element, so it's 0, 1 and 2, 3 and 4, so it's going to show me all three of them. Similarly, I can say give me everything before 2, and it will give me 0 and 1. It will not give me the second parameter, it will exclude the last item that is there. So number 2 it will exclude, so it will be 0 and 1. So that's how you can see it. You can also change the parameter, so I can say A of 1, instead of my string I want to say hello world. So that's why I said it's mutable, which means you can change it after you assign it. So if you see, my string became hello world over there. This, you can append items to your list. I can say a.append, let's say I want to append number 34, and now if I display it, you'll see 34 added to the end of the list. You can pop items by saying pop, and now if you look at it, the last item was popped. Similarly, I can pop again. Pop will always take the last item and pop it out. So if I run A again, you'll see it has only 4 items inside it. I can do reverse a particular string or reverse a particular list, and when I run this, it will say this because this is not the right spelling of reverse. And now if I display A, you'll see the item, the order of the list is reversed. I can also do sort. Now in this particular case, I don't have the same types, so it will not sort it. But if I have a list of same types, so for example something like this, random numbers added, now I say b dot sort, it will sort my array in an order 1 2 4 7. So that's how you can sort it. You can insert items at a particular location. I can say insert. Insert takes 2 parameters. It says, okay, what is the index that you want to insert at? So 0 1 2 I want to insert here, and I want to insert 34. Now when I look at this, I have 1 2 34 and 4 got pushed, and everybody is pushed by 1 index. So that's how insert is used. Other than that, I can add 2 arrays, 2a plus b, or 2 lists. So if you see, it took the first list, A list, and the B list, and then added them into one single list. So you can create one list with 2 different lists. If I want to, for example, multiply by 3b and run it, you'll see what it does is it took the list and created a list repeating it 3 times, b b b. So it took the elements and it kind of added them behind the previous list and created a list which includes 3 times the list that B was. So these are different operations that you can do with list data structure. Thank you. Hello, welcome back to data science class, and I'm Vivin Arana, and we're going to look at Python data structures tuples. We saw list already. Tuples are very similar to list, but they're like the ordered collection of elements, but they're immutable, which means that once you assign the values, you can't change it, you can't append, you can't do any of that you can do with list. So let's go and create a Python notebook, Jupyter notebook. How do I create a tuple? The only difference is instead of square brackets, we use rounded brackets. And as I mentioned, once you create it, you can't edit it or you can't modify it. So let me create a complex. I'm going to add one of each structure. So I have A. If I want to see the type of A, see it's a tuple. Now what else can I do? Similar, just like list, I can look at the different items inside here. A of -1, A of 2 to 5. So you can do all these different operations with this. You can also look at the length of a tuple. Say 5 elements. You can print. Let's create another tuple called as say B and add 3, 4, true. I can do A plus B. I can add 2 tuples into creating a single tuple. I can do the multiplication just like list, and it will add it 4 times into a particular list, the contents of B into a new tuple with repeating it 4 times. I can do something that's plus A, so I'm going to multiply it and then add a tuple behind it. So it's going to create it 4 times and then add A behind it. So that's another way of kind of repeating a particular tuple plus adding something to it. If I have a tuple of, let's say, numbers, I can do min, what is the minimum value, and I can do what is the maximum value. It doesn't depend on the order, but it depends on the numbers that are inside. It can kind of give you values, which is the minimum value inside tuple, maximum. I was not able to do it with these because they are different types and instances need to be same to find minimum and maximum. So that's how tuples work. Welcome to data science. So this time we're going to look at dictionaries, which is another data structures in Python. Hi, I'm Vivian. So let's start with a project in our Jupyter notebook. I'm going to create a new one. In dictionaries, how do you define dictionaries? So what are dictionaries? You saw lists are ordered set of items which are mutable. Tuples are mutable ordered list of items. Dictionaries are unordered. So the next question is, how do you actually access them? They're unordered, which means they can be in any location inside the data structure, but they're key value pairs. So you don't need index for that. You'll need the key to get the value of a particular item in there. And it's mutable. You can constantly change it. So let's create a dictionary to see how it actually looks like. I'm going to create a dictionary with key country and the value, say USA. You can create number of states that it has is, let's say, 50. I say what is the capital is, let's say, Washington DC. So this is my dictionary. If I run this, I can see the values. I can say type of D, it says dict, which is a dictionary. Now what if I want to, let's say, get only the keys available inside a particular dictionary? I can say D dot keys. Run it. You get dictionary keys are country, states, and capital. What if I just want to get values? I can say D dot values, and it will give me dictionary values are USA, 50, and DC. What if I want to change or add something? So let's say I want to add a key in here, D of president. As you see, I am not using indexes, I'm using key, and the president is Trump. If I run it and look at D, you'll see a new item added to it. It's added to the end, but it can be anywhere. It can be added anywhere since it's unordered. So it doesn't matter what you do. I can change a particular. I can say, let's say we decide to add one more state. So I can say states is 51. So this will update my states from 50 to 51. So you can update, since it's mutable, you can update, you can add items. If I have another dictionary, let's say population is 300, say population in million 300, and let's say GDP in billions is, let's say 20, some random numbers. Now if I look at D2, but what if I want to add both of them together? D and D2, so I can do D dot update D2, and this will give me D with all the existing items, plus it will update it with these two items inside the dictionary. So it added the two items to it. I can pop things out. So if I say, if I want to pop now, it will, since it's unordered, it will, you need to know which key do you want to pop. So let's say I want to pop president, and now when I look at D, it will not have president inside it. So that's how dictionaries work. It's an unordered set of items. You can recognize them by their keys and get the values assigned to them, and it's mutable. Hi, welcome to Data Science. I'm Vivin Arana, and today we are going to look at the large data structure sets. So what are sets? Sets are unordered items, not like lists. They are similar to, you can call them similar to dictionaries. So they don't have indexes, but they don't have keys too. They're unordered, unindexed collection of unique items. And when I say unique, that means there can't be any repetition. So one item can come inside a particular set only once. So it might be helpful if you want to remove the duplicates from a list. You can assign it to a set and you can see what items are there. So let's go and look at sets. So I'm going to create a new Python Jupyter notebook. I'm going to say set is, let's give some items to it. 1, 2, 5. You can say some strings. Awesome. Can give some complex variables of items. Data types I can give more, 3.44, 2, 5, 3.44. So if you see here, I'm trying to create a set with some duplicate values. What happens when I do this? Let's look at the output. So you see I have a complex, I have 1, 2, 3, 3.44, 5. Awesome, but it removed the duplicate, so it didn't accept the duplicate values inside this. And if you see the order, it's unordered. It didn't go in the order that I added. It just adds however it feels like it. You can add more items to it. I can say add 4, and then look at it. 4 is added. It will add it wherever it feels like. It doesn't have to be in particular order. It will not add duplicates though. If I say add 4 again, and if you see the output, it doesn't have 2 4s, it has only 1 4 because I've added 4 before. If I want to let's say update a particular, so I can just say update, say 0, 3.2. So what does this do? If you look at it, it added 3.2 and 0 to the particular to our particular set. So that's how sets you can add more items to it. You can remove 2. You can just say remove. I can say remove 0. Now if you look at the output, it removed S. So you can remove, you can update, you can add items to it. Now next thing that you can do with sets is, let's create 2 sets, separate sets. 1 equal to 1, 2 and 3, and set 2 equal to A, B and C. So I have 2 different sets, set 1 and set 2. I want to do a union of set 1 and set 2. What does union function do? When I pass set 1 with set 2 and say union, it will add both the sets together and create a union of both of them. I can do also intersection, set 1 dot intersection of set 2. Now if you look at 1 and 2, what is common in between both of them? There's nothing. 1 has 1 2 3, 2 has ABC. So this intersection doesn't work fine with things that you have are unique anyways. So I'm going to say 2 3 4 and 5. I'm going to create another set, and now I'm going to copy this intersection code and pass it 3. Now if you look at this, it'll say in between 1 and 3, 2 and 3 are common, so it gave me numbers set with just values 2 and 3. So that's how sets work. It's unique numbers inside an unordered, unindexed collection of items. Welcome to another class of data science. This is Vivian here. Today we're going to look at conditional statements in Python, which is if else. It's usually used to make decisions. If something is true, then do this, if or else do that. So if else works in a way that if a particular condition is true, so you have to give a statement, and if it's true, you execute that. If not, do something else. So for example, let me create a new Python 3 Jupyter notebook. In here, I'm going to give a equal to 2 and create b equal to 3. Now in this case, if I want to check if a is greater than b, this is how you kind of go ahead with it. You give a colon and then indent it, because that's how you know that this is whatever is writing is in the body of if print a is greater, and else, I mean, if you just run this, you know nothing is going to print because a is not greater than b. But if I copy or just continue here and say else colon print b is greater. So now I run this, it says b is greater because b is greater. Similarly, I can change the, let's say if less, even though it doesn't make sense, a is greater because a is less than b, you can change the values. But this is your statement which will be kind of evaluated for if it's true or false. And if it's true, this will be executed. If not, the second else will be executed. You can do it similarly for some list. Let's say if I create a list of, can't use the list keyword, can say 1 4 and 6, 1 4 and 5. Now I want to see if 3 in list 1. So does 3 exist in list 1? If you see 1 4 5, so that means 3 doesn't exist. So I can say print it's there, else not there. So if I run this, it's gonna say not there because 3 doesn't exist. If I say 4 and run it, it's gonna say it's there. So that's how if else conditional loops work, where it actually gonna check if a particular condition is true, then do it, else do something else. It's quite helpful in programming and we'll be using it quite a lot. Hi, welcome back to Data Science, another class for Python loops. Hi, I'm Vivin Arana. In this particular class, we're going to look at different loops that are available. You want to loop through a list. A list has a bunch of different items. Let's say it has 10 items. You want to loop through them and do something with each and every item in there. So that's when you can use while or for loops. Let's look at some examples. Let's go and start a Python Jupyter notebook. In here, I'm going to say a equal to 10. Now it doesn't have to be list. It can be a particular statement. For example, I can say while a is greater than 0. So does it meet the criteria? A is 10, which means a is greater than 0. So I'm going to say if a is greater than 0, print a, and after that reduce a by 1, subtract 1, so a becomes 9, and again it will check. A is greater than 0, it's 9, so it's true. Again it will go, it's going to go through this 10 times until it finds that a is greater than 0. You can always say greater than equal to, so in that case it will run it 11 times. Oops, since it's already executed, let's run this again and then this. So if you see 10 to 0. So that's how you can kind of iterate over a particular statement to do things bunch of times. So that's why loops are used. That's what while loop is used. You can also do that for, let's say if I have a list with bunch of items, I say 1 4 6 8, and then I'm going to make a variable a equal to 0, and then I'm gonna say while I is less than length of the list that I have. So I'm saying while I is less than length of list, so I is 0. So list I has 1, 2, 3, 4 items. So it's of course less. So what should I do? I want to print the list 1 and the element at ith index, which is 0. Once I'm done with that, I want to increment I by 1. If I run this, you'll see it's going to go through each and every item. So I index is 0 initially. So it's going to say, oh, index at 0, 1. Then I'm incrementing it to 1. So while I is less than length, what is at 1? 4. It's going to display 4. And it's going to keep on doing this until it reaches to the last index where I is less. So I becomes 0, 1, 2, 3, and then 4. When it goes to 4, since there's length of list of is 4 and I is 4, so it's not less than, it's equal. So that's when it will quit the loop and go to the next statement. Similarly, there is for loop. In for loop, you can say for element in our list, I want to print the element. In this case, what happens is you don't have to increment anything, because every time what for loop does is it goes through one item at a time automatically, so you don't have to give an index. In this, I'm saying for element in list 1, so it will say, okay, what do you want to do for the first element? Print it. What do you want to do for the second one? Print it. Third one, print it. Fourth one, print it. So that's how for loops work, and we're going to use this quite a lot, and you're going to learn how to use while and for loop in real scenarios. Hello, welcome back to Data Science. This is Vivian here, and today we are going to look at Python functions. Now, functions are something that we've been using quite a lot since the start of this tutorial, but we have not seen how to create our own functions. Usually functions are created when you are writing some code repetitively and then want to add it in an organized block. That's one reason. Again, it makes your code look more organized, better to use and reusable. So let's look at how to write functions. I'm going to open a new notebook, and here usually some of the functions that we used is, one of them is print hello world. So if you look at this, print is a function that is built in, and I'm giving a parameter or an argument. You'll hear those interchangeably. So parameter or an argument, and it will call this function, and the function will do is print this value. Now if I want to create my own function, let's say I am printing values over and over again, I want to call a function. So the way you write a function is start with def, which definition, and then name of the function, let's call it main, and colon, and below it the function body. In our case, I'm just going to say print I am main. Okay, so that's how I define a function. And now to call a function, I just call the function this, and if you see this thing, call this function, and it printed I am main. So that's a basic definition of a function. What if I want to give some parameters inside a function? So if I want to create a function and I have a parameter, let's say a, I am main with value, you can say comma a, and now when I call it, let's say main 24, and if you see, it will take this function, call the function, pass the parameter value 24, and when it's printing, it's going to get that value and display it at the end of it. So that's how parameters work. What if I want to give two parameters? I can say, let's say I want to call add function, add two numbers, and I'm passing a and b, and here I can say sum is a plus b. Print that, add two numbers, and here I'm going to say 2 and 3. Can enter, and if you see, it's going to call this function, pass 2 and 3, and take the sum of both of them and add it up. 2 plus 3, 5 is what is displayed. I can call it again with, let's say 20 and 35, and there you go. 55 is, so 35 plus 20, 55. I can call for subtraction. I can create a method where I'm doing regular things over and over again and add it to that. Now what if I want that value to be returned back to me? In this particular function, let's say if I add something called as return, let's get rid of this. Return is the keyword. What it does is it gives the value back to my calling functions. For example, I say a or sum equal to, or sum of two numbers equal to, add two numbers, and I say 34 and 67. And now sum of, when I want to sum, see what, so what happens is it will call this function, pass these values, and return a plus b. It's going to take these numbers, add it, and assign it back to sum of two numbers. If you look at it, 101, which is the addition of 34 and 67. So that's how you can get values. Another way, another function type declaration is or something called as anonymous functions. Anonymous functions are functions without no name. So think about this function without a name. So if I copy this, paste it here, don't add any name, this is an anonymous function. The way anonymous function works in Python is by using something called as lambda. So if I say lambda and then give the parameter that I'm passing, for example, let's say a, and I want to return from this, let's say a plus 5. So if I give it 5, it will give me 10 back. If I give 20, it will give me 25 back. So I can assign it to a variable, and now if I print x, it say that it's going to call this function and get this value inside it. So the reason it didn't give it is because it's lambda here. So the way to get output from it is I need to pass this a parameter, because without that a parameter, it's just a lambda function. So if I run this, if you see, 3 is what I gave, and it gave me 8 back. Similarly, I can say x of 45, it'll give me 50 because it adds 5 to it. Another pretty cool place where I can use it is with different functions, built-in functions like filter, map, and reduce. What are these filter, map, and reduce? Filter lets you filter out a particular list or an iterator and get whatever you are interested in. Map will actually try to modify a list that you give to it and then give you an output. And reduce is gonna look at all the items and give you a solution out of this. What am I talking about? Let's look at some of these functions. Let's say if I have a list 1 with the values of, let me just put some random numbers in here. Okay, so I have a list here, and now with this list, what I want to do is I want to call the filter method. Now the way filter method works is it takes two parameters. First one is a function and second one is the list. So I can give list1 as the second method, and instead of giving a function, I'm going to give an inline or an anonymous function, which is lambda, and I'll say it can take a parameter a and give me everything inside this particular list which is greater than 20. So what it's doing is it's kind of using this list1 and taking each item inside it using the filter method and give me every number which is greater than this. So I want to put this inside a list, so I can just say give me this list. I'm going to assign it a list, my list, or let's call it my filtered list. Run it, and now if I want to print this out, it should give me 45, 63, 232 and 77 because they are larger than 20. So I run this, and if you see 45, 63, 232 and 7, so it will take a list and create a new list and apply this function to each and every element to check if it can filter out. So that's how filters work. So if you want to build a search engine with, let's say, a list of all the names of fruits, and you want to filter based on a particular season, you can have key value pairs and then filter it out from there. Another cool function is map. So how does map work? Map also does same thing. It takes two different parameters. The second one, as you probably know, is list, and the first one is a function. So I'm going to say lambda, give me all the elements inside it but reduce 5 from it, from each and every element, and it will put it inside a list, new list, and I'm going to my mapped list. So it takes a list and maps it as the name says, maps to this particular function for each and every element. Let's look at the solution, and you'll see 45 became 40, 3 became -2, because subtracting 5 from each and every function for every object inside a particular list. So that's how map works. The next function that we're going to look at is reduce. Reduce by default doesn't show up, so what we have to do is we have to import from functools import. So there's something called as functools which is built in, and from that I'm importing reduce. Now once I have that, I can run reduce. It takes two parameters, just like everything else that we did before. First one is function, so I'm going to say lambda a comma b, give me a plus b. So what it does is reduce will take the first parameter and second parameter. What you want to do is add it, then take the one solution from this and take the next one. So first, like let's say 45 plus 3 becomes 48. 48 will take is assigned to a, and 63 assigned to b. Add it again, add it again, add it again, add it again, until it gets one single value. So I'm going to say value equal to whatever comes out of it. Let's print it out, and there you go. 432 is what is addition of all these numbers. Now I don't want to go and count all these, but I'm going to make it easier. Add these 5, run this again, 15. So 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15, and that's how I got this 15 value here. So these are different functions, and we're going to write a lot of functions inside our project, and we're going to use some of these filter, map and reduce to kind of do our work, some of the things that we want to do for filtering easily using these functions. Welcome back to data science class. This is one of the most important topic we'll be covering. This is about object-oriented programming. Hi, this is Vivin Arana. Let's talk about object-oriented programming. Object-oriented programming is your programming around objects. That's why it's called object-oriented programming, of course. But what it does actually mean is it kind of defines the functions in a way. It defines the objects or anything that you use inside your coding in such a way that it feels more realistic to real life than the procedural programming that we've been following before. So what happens in object-oriented programming is everything is defined using a class. So you kind of architect everything with a class. As they say, class is a blueprint and the object is something that you created from it. Now it makes sense if you hear it quite a lot of times. If you think of construction case, the blueprint that they have to build a house doesn't actually is a house. It's a blueprint. It's a flat paper. When you actually build the house, that's where the object is from, and you build the object from the class. So class is nothing but just a definition, whereas the object is the actual object that exists in memory. You can think of it as, let me give you another example. You can think of it as a recipe. A class is a recipe. You can't eat a recipe, but with that recipe you can cook some food, and that is an object, something that exists in real life. I think that makes more sense. So a class is nothing but a recipe, and object is the food that you cook from that recipe. So let me give you some example. Let's go ahead and create a new notebook. And to start for class, I'm going to say class and give an example of food. I'm making a class called as food, and inside a class, what does a class actually contain? A class contains properties and behaviors. What are properties and behaviors? Properties are nothing but they are variables which tell me what type of food it is. For example, I can say cuisine. I can say how spicy it is, level of spicy, how much time does it take to cook, how many ingredients does it have. So those are properties of a class. And behaviors are nothing but functions. Functions like, okay, serve the food if it's ready, eat the food if it's ready. So I'm going to create a few behaviors. So I'm going to say cook food, and behaviors are function, and it takes an object of self as a parameter. So this is a basic definition of how you write a class, and inside this function will, let's say, just a print cooking food. So that's my first function. I'm going to write another function. I'm going to say eat food, and you pass the object print, and I'm saying eating what I cooked. So this is my a very simple class that I've created. Now why do I have to give this self? The thing is, I need an object to pass when I need to call a function, because you can't, as a class object, if an object doesn't exist, you can't run a function from that object. So what I'll do is I'll create an object. I'm going to say f1 equal to food. What this does is it will create an object f1 from this particular class, and it will call it food. Now if I call cook food method, it will run that and will call that function and print it out. So you don't have to pass anything inside here, because it takes this object as an argument and prints it out. Similarly, I can do f1 dot eat food, run it, and there you go, it prints out, it runs that function. If I create a something different variable and try to call this, if I say a equal to something, it's a string, it belongs to the string class. So if I say a dot cook underscore food, it will not work because it doesn't have a function inside the string class which is cook food. It will only work for objects that are created using this class structure. So let's go ahead and set some more objects inside here. So I'm gonna create again class food, and I'll say I want to define set ingredients. So what I'm doing right now is I'm setting different properties. So I'm saying that this particular food has ingredients. So if I want to set ingredients, that means whenever you create this food object, you are going to create, you're gonna send some ingredients to it. So I'm gonna say number of ingredients, let's call it number of ingredients that we have. The way you define and the way you assign it, you say ingredients. If I spell it wrong once, I should spell it wrong as many times as possible, right? So I'm just going to copy and paste it. I'm going to call another function. I'm going to say set cuisine. What cuisine does it belong to? Self cuisine. So these are all the different properties of these. So if ingredient is a property of food, cuisine is a property of food. So I'm going to say self dot cuisine. As I said, if I mistype it once, should do it again. And next one is, let's say, show the number of ingredients it has. This is a behavior message, so I'm not gonna add anything to it. Return. Oops. Self dot ingredients. I think I copied. Okay, so there you go. I have that. Similarly, I can do the same thing for cuisine. I can say show cuisine, so it can tell what it is, and I can also have these functions that I've created before added to it. So I have my entire class with bunch of different ingredients, and it has some behaviors like cook food and eat food. So let's go ahead and create a food object. Okay, now I have that. Now to set the ingredients, how many ingredients it has, you can do set, call this function, I'll copy this, say this has 10 ingredients. I can say f2 has, what cuisine does it belong to? I'm gonna say this is Thai. And now if I want to, let's say, see the output for what all ingredients it has, I can do f2 dot show ingredients. It has 10 ingredients, which is right. f2 dot show cuisine, should say Thai. Perfect. f2 dot and the other functions, and forgot the brackets. and f2 dot eat food function. That should work as it is, and there you go. So it works everywhere for it. Now instead of doing this, of setting ingredients, setting cuisine, you can use something called as constructors. Constructors are nothing but when you create an object, like in here, you can actually pass some variables like ingredients, Thai, cuisine, all these things. You can pass it while you are initializing a particular object. So for that, we can use something called as initializers or constructors. So let me take let's create a new class altogether. Enough with food, so I'm going to go with cars. It kind of makes me hungry when I talk about food too much. I'm going to create an initializer. The way you create initializer is two underscores init underscore, give the self object. Next, let's say I want to give year, make, model and color of my car as the parameters. Now I can say to assign this. So this is how you write a constructor, where you can pass all the variables that you want to set while you're creating this particular objects from this particular class. So I can say self.year equal to year. To repeat this, make model, let's say make model and color. So this is how you can, when you're creating class of car object, you can initialize all these variables and it will be available for the object. Now let me just say display car details. Let's create a function, and inside this to pass self, and in here I can say print car is self dot here. So it will print me what year it is, what is the make, what is the model, and what is the color of this particular class. I'm gonna go run it. So this class is created. Now I need to create an object for this. So I'm going to say c1 equal to car. I'm going to say it's a 2004, so year. For year I'm going to give 2004. For make, I'm going to say, let's say BMW. I'm going to say make model X5. Make is BMW, model is X5, color is red. So I created that. Now if I say c1 dot display car details, I will see car 2004 BMW X5 red is what object that I've created inside c1. So that kind of gives me an idea of how you can use initializers and initialize the entire object just with one line while initializing, and then use the behaviors or functions to do whatever you want to do, instead of doing set again and again. You can use combination of both too, but this is much more easier when you're building it. Next thing that I want to talk about is inheritance. One of the very important part of building classes. So let's say I want to create a car and I want to give it basic functionalities like all these things, but then I want to also create a class called a sports car and an economical car. So there's two different classes. Both these cars, let's say economic car and sports car, both have the same functionality of a car. They all have a year, make and model and color. The only thing is probably the horsepower is much more in sports car, whereas economical car, the miles per gallon is more what you get from it. So I'm going to go and create another class called as sports car, and inside this sports car I am going to say definition, create a function called a display sports self, and I'm going to say print I am a sports car. So this is nothing different from what we created before. The way you can use inheritance is just go to the class definition and you say this belongs to class category. Similarly, I can go ahead and create one more, and I can call it eco car, display eco, and can say kill car, something like this. Now when I create, let's say C2 equal to, I can use the same function, because since it's inheriting from car, it's also going to inherit all the functions available there. So I can say this is a sports car, BMW, I can call it M5, and it's blue in color. Run this, and now if I say C2 dot display, it will give me the 2004 BMW M5 blue. What if I call C2 dot, oh, the mistake that I did was, instead of creating it as a sports car, I created a car, just copy pasted stuff. Run it again. If you see, nothing has changed because sports car inherits from car, so it's going to display. But what if I call display sports function here? It will say I'm a sports car. But what if I call this function in here? It will give me an error because this function doesn't exist in a sports car. Sports car has its own functions, which is this one, display sports, and it has initializers and display car details, but doesn't have economy, because economy car is a sister class, which, and both of them inherit from car. So similarly, I can do something similar with for eco car. I'd say go ahead and try this out and let me know if it doesn't work. I'm going to go ahead and go to the next part of it, which is overriding init methods. What if I want to have a different initializer method for my sports car function? So what I can do is, let me copy this class, and I want to add an initializer method for this, which is very much similar to this one. So this is called as overriding your init method. Inside this I have everything same except for I have horsepower. Now I don't have to do all this over again because it already exists in the super class or in the car class. So that is called a super class when you are subclassing. I can say super, and I can call the initializer method of that and pass all the things that it has, which is these things, and the only thing that is left is horsepower. Self dot horsepower equal to horsepower. I'm a sports car with horsepower of self dot horsepower. So when I create this, okay, there is some display sports unindent. Okay, so I lost the indentation when I did this. Let me just make sure it's properly indented. Okay, let's try again. Okay, there you go, it worked. Now I'm gonna create C3. I'm gonna call it a sports car, and I'm gonna pass everything. Let's 2010 year. I'm gonna say Audi. Gonna say model R8. Color is white. Horsepower is, let's say, 500. Now if I say C3 dot display sports, it will give me I'm a sports car with horsepower 500. And if I say C3 dot the method from my parent class, super class, it will tell me 2010 Audi R8 white. So it worked for both of them. So this is how you can reduce your programming by making sure you write as less code as possible, by separating out what goes in the main class and what goes in the subclasses. Now there's a very common question that everybody asks after this: what if we want to inherit from two different classes? Let's say you want to make a flying car which has properties of both a plane and a car, and also has its own properties. So is this possible? So it's plane and a car but it's a flying car. So we already have car. So whatever we did till now, where you are inheriting from one single class, is called a single inheritance. Now what the thing that we have in question is, with multiple inheritance, is you are inheriting something from the car and you are inheriting something from plane, and that class is flying car, which is inheriting from two different classes, and that thing called as multiple inheritance. So let's give an example. So we already have a class called as car. I'm going to create a plane class, and inside this I'm going to write a function, plane, let's call it name, which has self and name. Self dot name equal to name, so assign it a name. Next thing, define display plane underscore details and self. So this will display me or print saying I am a plane named comma self dot name. So that takes care of my plane function. Now let's make a class called as flying car. So when I have flying car, that means it's subclasses from car and it's subclasses from plane. Now inside here I can define flying car name, and I can call it self comma fp name, just to make a different type of variable. Self dot fp name equal to fp name, and define display details self print I am a flying plane. There you go. Planes fly anyways. Flying car. So I'm gonna make now an object called as flying car 1 flying car. Now I want to give some parameters, but if you see, flying car doesn't have an initializer method, but since it's subclasses from car, that means that I can give it properties like, say this is 2020 and my make is Vivian. I started making flying cars, and model is awesome, and the color is, let's give a green. That's my flying car. Now if I say fc1 dot plane name, so which means I called a function from car, now I'm calling a function from name. I'm gonna say awesome plane, right? So I can do that too. I can say fc1 dot flying underscore car underscore name. So I'm calling a function from flying car, so I can call functions from anywhere as long as it belongs to either flying car or plane. And this one I'm gonna say awesome car plane. Now if I call fc1 dot display car details function, this will call the function from car class. It says car 2020 Vivian awesome green. Next thing is fc1 dot display. As you saw that we can call methods from the parent and the class itself. Similarly I can call plane, let's copy it so I don't type wrong, and it will say I am a plane named awesome plane. Now I want to say fc1 dot display details. This is from here where it should say I'm a flying car. I should have said self dot fp name comma and then here I can say display details. Let's say I'm a flying car. The reason it didn't work is because when I probably have to run each one of them. There you go, I am flying car, awesome car plane. So that's how you can do multiple inheritance, single inheritance, overriding, do constructors, and a lot of things. We did a lot of things here, so I'd want you guys to go ahead and then practice it out, try to understand what I did. If it's difficult to understand, get back to me, write it on the comments. Try to go through all the Python classes that we did here and try to understand what we are trying to get here, because this is very difficult, I understand, but once you start doing some real world projects, that's when you'll understand, and that's what we'll be doing later on in this course. I hope you enjoyed. Thank you for watching, and keep me posted with your questions. Hello, welcome to Data Science. This is Vivin here, and in this section we will be learning different types of libraries that are available in Python, which are very useful while doing data science or writing code using Python. So NumPy is something that is used for numerical complexity computing or can be used for mathematical operations. NumPy actually stands for numerical Python. So anything that has to do with numbers. It's a core library for numeric and scientific computing. It processes multi-dimensional arrays. It makes the computing and processing much easier. Now there's a lot of different libraries that we will look at in this particular section. The most three popular or common libraries that we'll look at is, in this case, is NumPy, which is our numerical Python. The next one is Pandas, and the one after that is Matplotlib. So these are three popular libraries that are available for Python, especially for data science. So NumPy, we'll start with some examples. In future sections, we will go through some real life examples of how to use them. But just for an introduction, I'm going to go over some basics of NumPy. So let's start coding. I'm going to go and start a new notebook, new Python 3 notebook. I'm going to save it as, let's call it Python NumPy. And I'll start with let's start with single dimensional arrays. What are single dimensional arrays? Now if you want to use NumPy library or any library, first you have to import that library in your code. So I'm going to say import NumPy, and you can directly use NumPy from here onwards, but a lot of practice is to use shorter form of it. You can use N, you can give your own name for if you want, but a common practice is to use it as NP, which is NumPy short form or alias, and that's what we'll be using here going forward. So how does this work? So let's say if I have a list which is a bunch of numbers, I can say 1, 2, 3 and 4. So I have a list with these 4 numbers, and I want to create a, let's say an NumPy array. The way you create it is you say NP, which is our NumPy of the handler here or variable, dot the function that exists is array. I want to create a single dimensional array, and this is a single dimensional array. So I can directly give list 1, or I can even copy paste these items inside here like this. So once I give that, now I have my array. Let's print it out. So if you see, this is a single dimensional NumPy array. It's also called as one dimensional, but if you look at type of N1, it will tell you NumPy n dimensional array, which means it is the n here is 1 because it's only one dimensional. If you want to do a two dimensional array, the way you can do it is I can say n2 equal to np dot array, and inside this I can give list 1 and list 2, or I can directly write the list inside something like this. So I create an array of multi-dimensional. This is the first dimension, say 1, 2, 3 and 4, and I can give, let's say 5, 6, 7 and 8. So the first dimension has 1, 2, 3, 4. The second dimension has 5, 6, 7, 8. If I print it out, I can say n2. So if you see, this is the first dimension, this is second dimension. It's like 2 by 2. You can actually look at the shape for a particular n dimensional array by giving n2 dot shape. So it will tell you it's 2 by 4, which means it's a two-dimensional array with 4 elements inside it. Similarly, if I want to look at the shape of the first one, it has 4 items in it, but it has no dimensions since it's a single dimension. So it has 4 items array. You can actually change the shape of an array. So if you look at n2 again, and if I say n2 dot shape from 2 comma 4, I can say 4 comma 2 up, I think I have to say equal to 4 comma 2. Now if I look at n2, oops, I think I changed it to not a data cell. I'm gonna get rid of this. n2. Now if you see, it kind of took these numbers and created a 4 row 2 column array. So this is how you can change shapes. You can change it to, let's say, n2 dot shape equal to 1 comma 8. Now if I look at n2, you'll see one single item with all the 8 objects inside it. So this is how you can play around with shapes of multidimensional array. You can have as many as you want inside it, and it will helpful. Now here I was creating an array with numbers. What if I want to initialize an array and add the values inside it later, but I want to initialize it as all empty or 0 elements? I can do that using a function called as zeros, and I'll have to set the dimension, let's say 1 comma 2. If I print this, you'll see it created a one particular item with 2 items inside it. Similarly, I can say n4 equal to np dot zeros, and inside there, let's say give a big number, 15 comma 15. And did I do wrong? Okay, yep, I forgot the inside bracket. np dot zeros 15 comma 15. Up, forgot this. And now if I look at n4, if I look at n4, I'll see a 15 by 15, and all the current fields added, all the current items are added as 0. So that's how you can initialize an item with all zeros. But what if you want to add a particular number inside it? So let's say I create n5 np dot, I can say full. So that means fill my array, which is of the size 2 comma 4 with all elements 10. When I run this, you'll see it creates 2 by 4 matrix with all the elements with 10. So that's how you can create an array with a particular number initialized inside it. I can also give a range. So to give a range, I can say n6 dot a range, and this size, let's say 10 comma 20. Oops, sorry, np. And now when I look at n6, you'll see it created an array, single dimensional array with 10 to the 19, because it doesn't include the last item inside it. So it created from 10. If you want to include the last one and start from, let's say 11 to 21. Oops, I think I want to do, there you go. And now you have 11 to 20. So you can give a range. What if I want to give a range but with a particular interval? You can always give the range, and then let's say I want to give step of 5. Let's change this number to 1 to 100. What this does is it will create 1 to 100, but it will give a step of 5. So 1 plus 5, 6, 6 plus 5, 11, 11 plus 5, 16, so on until 96. 96 plus 5 is 101, which is outside 100, so it will not print that. You can also start it from 0. And this way it's 0, 5, 95. It will not add 100 because 100 is the last number in this, and it doesn't include the last number. So that's how you can create an array with a particular range with a particular step inside it. Next thing that I want to show is how do you create an array with random numbers. So there's a function called as random, and I want to fill this with random integers, and those integers start from 1 and end at 100 and 5 items. So what I'm saying is I want random integers inside my array. I want only 5 items. It can range from 1 to 100. If I run this, and 8, there you go, I have 5 random numbers, 6, 33, 86, 2 and 28. If I run this again, I'll have different numbers, because every time I run it, it will create random numbers for me. So this is how you can initialize an array with random numbers. Now we've seen all the functions of how to create, initialize. Now what if I have two different arrays and I want to stack them together? So let's start with again n1 equal to np dot array and add 10, 20, 30 inside my first array. I create another array n2 np dot array. Inside this I'll add, let's say, 11, 21, 31, and now I want to stack them vertically. What does that mean? Let's do it and see. So if I say np dot vstack, which means I want to stack n1 over n2 vertically. How does it look like? Something like this. So it takes two arrays and creates a multi-dimensional array, two-dimensional arrays in this case, since I've given 2, and adds the first over second. If you had 3, n1, n2, n3, it will stack all three of them one over another. So you can stack multiple arrays into one single multi-dimensional array using vertical stack. You can also stack them horizontally by saying np dot h stack, horizontal stack, and in this again n1 comma n2, add it to n4. Now if I print n4, you'll see they are stacked horizontally, which means next to each other, 10, 20, 30, 11, 21, 31. There's one more stack which is called as if you see, all of them were stacked in a row order. So there is a function called as column stack, and you give the array n1 comma n2. In this case, what it will do is it will take first number, second number, stack them next to, put them in an array, second, so column wise it will stack my arrays. So if I print this out, you'll see took 10 and 11, 20 and 21, 30 and 31, and stack them next to each other. So this is how you can stack multiple arrays together. Now if you remember sets from before, what we did in sets is you could actually do intersection and difference and see the different differences in particular sets. So similarly in this you also have something called as difference and intersection. So how do we do that? Let me create from start another array, since I need a larger array for this example. I'm going to create an array 10, 20, 30, 40, 50, 60, and then I'll create another one, call it n2. Inside this array I'm going to add same numbers, 40, 50, 60, 70, 80 and 90. So I have these two arrays n1 and n2. Now I want to see what are the common elements in these two arrays. I can create np dot intersect 1d, that's the function, n1 comma n2. And now if I run n3, you'll see it will look at the first array and second array and intersect. What do intersect here? So 40 and 40, 50 and 50, 60 and 60, they're intersecting, which means they're common in both the arrays. That's why it created a new array n3 and added those numbers inside it. Similarly, I can do something called as set diff 1d. What this does is it checks what is available in n1 which is not available in n2. What do I mean? Run this. So if you see 10, 20, 30 is available in n1 which is not available in n2. It doesn't care about the things that are available in n2. It takes the first element and looks what's available in n1 but not in n2. Similarly, you can do n5, just change the order. Now in this case it should be 70, 80, 90, because it looks at n2 and sees what is available in n1, 40, 50, 60, remove those and give me whatever is left. So if I run n5, you'll see 70, 80, 90. show up. So that's how you can do intersection and difference among the arrays that are available. Another thing that you can do is you can add up all the numbers. So let's create n6 and say np dot sum of n1 and n2. Give me an array addition of both of them, n6 600. Now how do I know this is right? Just go ahead and add all these numbers and you'll see 10 plus 20 plus 30 plus 40 plus 50, and it should add up to 600. So that's what this does. np.sum takes a bunch of arrays and then adds all the numbers inside that and gives you sum. That's what sum does. Now what if I want to look at the axis? Like let's say I want to add all the numbers in a particular axis. What do I mean by that? Let's create n7 np.sum n1 comma n2, and I say axis equal to 0. In this case what it does is it will take the numbers. Let's say, where is my n1 and n2? 10 plus 40 50, 20 plus 50 70, 30 plus 60, and it will add all that items. So it will take each and every element and add to its neighboring counterpart, and that's what it creates an array. So that's what axis 0 does. Similarly, if I change it to axis 1, in this case it will go add all the numbers, add it to the first element, add all the elements, add it to. So that's my axis 2. So you can do axis 1 or axis 2. So think of it as x-axis versus y-axis. It's quite helpful when we actually do some real implementation in future sections. Next thing that I want to show is basic arithmetic operations that you can do with your arrays. So let me just copy. As you can see, I have numbers 10 40. So I can do is, I can say, let's take this here so it's visible to us. Okay, I create n8 equal to np or n1 plus 1. So this is the addition operation. What it does is it will give me an array where it will add 1 to each and every item here and give it back to me. Similarly, you can do subtraction, so it removes 1 from everyone. You can do multiplication. Now multiplication of 1 is, so I'll just do 2, and you'll see multiply by 2 20, 20 into 2 is 40, 30 into 2 is 60. So it does multiplication. Similarly, I can do division, 2 divided by 5. So 10 divided by 5, 2, 20 divided by 4, 5, 4. So it does division operations. So these are the basic arithmetic operations that you can do with your NumPy functions. Next one is there are some common functions that we use for statistics. You probably heard of them: mean, median, and standard deviation. Mean and median are measures of center, of where the actual center is, but they use different algorithms for it. Like mean is nothing but arithmetic average, where median is the center element. If you put all of them together, I'll kind of go over that in a minute, but just it's a center element. If there's two numbers in the center, then it takes the average. What does it mean? We'll look at it in a minute. And standard deviation is a measure of spread, of how it's spread. There's a particular algorithm, so there's a formula for it, deviation formula. If you just Google it, it will give you this formula, and we'll go over it, what it actually means. So let's go back here first, and let's create an array, np.array. Add some numbers inside it, just some, say 10, 20, 30, or I'll just use the one that we have here, 10, 20, 30, 40, 50, 60. Once I have this array, I can say mean number equal to np dot the built-in function. So we don't have to do the arithmetic for it. I run this, mean num is 35. Why? Because the average of 10 plus 20 plus 30, 40, 50, 60 divided by 6 equal to 35.0. If you don't trust me, I'm gonna open up a calculator. 10 plus 20 plus 30 plus 40 plus 50 plus 60 divided by 6 is 35, and that's the value that we get here. Similarly, for median equal to, since we have 1 2 3 4 5 6 and all of them are in order, you'll probably see the center element is 30 and 40. Now 30 plus 40 divide by 2 is 35. So np dot median of n1 will give me 35.0. What if I had one more number at the end, let's say 80? In this case it will add all the numbers. For the mean it will say 41.42 because average of those numbers. You can use the calculator and try it out. And median will be the center element. In this case, since we have 3 elements here, 3 elements to the right, and they are in order, so it will be 40. Now if I run this, it's 40. If I remove this 40 and add it to the end, if you look at it, it will not cause any problem there, and at the same time it will not cause. What it does is it takes these numbers, puts them in order, and then takes the median. So that's how median works. The next one is standard deviation. Now I can quickly do a standard deviation. How does it work? I say np dot standard deviation of n1 std num 22.314. Now how does this math actually come into picture? Now I'm not going to show it with this number. What I'm going to do is I'm going to change this to a much simpler number, 1 2 3, just to show how this formula works. Run this, run this, and run this. You see 0.81649 whatever I got here. Now let's say I have, what number do I have? I have 1, I have 2, and I have 3. These 3 numbers I have. And what do I need here? On the top I have x1 minus mu. Mu is nothing but the median. So in this case the median is 2. So I'm gonna say this is number minus mean. In this case mean is 2, so which means the number that goes here is 1 minus 2 is minus 1, 2 minus 2 is 0, 3 minus 2 is 1. So that's where I get this part. Now square of that is, so let's say this one square is minus 1 times minus 1 is 1, 0 square is 0, 1 square is 1. That made it easier. So this is what I have now. Sum of, so according to this I need to sum whatever comes out of this, and if I go here, sum of 1 plus 0 plus 1 is 2. So sum of all the numbers is 2. So I get 2 for the numerator of it. Denominator for the bottom part is number of elements. I have 3 elements. So 2 divided by 3 is this particular thing. Now square root of that. So let's open calculator. Go back here. So open the scientific calculator because it has square root. Now I said 2 divided by 3 is 0.66. Now what is square root of that? 0.816. And if you see, that's how we get the standard deviation number. So this is the formula that is used, and that's how we get standard deviation. So these are 3 different methods which we'll be using quite a lot in our machine learning algorithms, or when we set up our code: mean, medians, and standard deviation. I just wanted to go over the basics over that, just so that you understand how this works. And let's move forward to next one. The last one that I want to talk about is save and load. So if you want to save a particular array, you can just say np.save. You have to give a key or tag for it. I can call, let's say I want to save my n1 array inside my array. You can say n1. So it will save it in, and later on if you want to load it, let's say nload equal to np.load the name of the array, and I have to give an extension py or npy. And if I print this nload, you'll see I get the array that I saved. So you can actually, we will be saving some items for later use and then load it in somewhere else. So that's how you can save a particular array and load it up later. So this is basics of NumPy, some of the things that we've done. Look at it try to go through all these different functions, understand how it works, and if you have questions, let me know in comments below. Hi, welcome back to Data Science. This is Vivian here. Today we will go over pandas, another library that is available with Python. In the previous class, we saw a library called as NumPy. In this one, we're going to go another popular one, which is pandas. In the previous one, we saw NumPy was used for numerical operations. Pandas, which is short for panel datas, is used for data manipulation and data analysis. It provides single and multidimensional data structures. In NumPy, so you got data arrays. In this, you get a data structures, and those data structures you can manipulate. It's huge amounts of data that you can manipulate without writing too much code. That's what pandas is used for. It gives you two different, you can start with single dimensional data structures, which are also called series object, and they are key value or kind of labeled arrays where you have indexes like 0, 1, 2, 3, which we have in typical arrays, but also you can, since the reason it's called labeled is those indexes you can change it to whatever you want. Similarly, there's multidimensional data structures which are called as data frames. They are in type of you can think of it as CSV or a table kind of format where you have items and each one of them have labels on the top and it has bunch of data sets inside there. So that's what we'll be working with. We'll start with pandas. Let's start a Jupyter notebook, Python 3, and I'm going to call it Python pandas. Now as we imported NumPy, similarly we can import pandas and give an alias as PD, which we'll be using it going forward. Now if I want to create a data set or data structure single dimensional, I can use series, and inside this I can give, this is as simple as it can get, can give a list of items 1, 2, 3, 4, 5. If I look at A, if you see these are the values and these are the indexes 0, 1, 2, 3, 4. It looks like an array, but it's not. It's a data structure which is of the type called a series. I can look at the type, and you see it says pandas core series object. That's what it is. Now if I want to customize these keys, I can say let's create another one, pd.series, and inside this again I'm going to do the same thing, 1, 2, 3, 4, 5, similar, but I want to give indexes to this. So you can just say index, that's how you give indexes, and you can give an array. Let's say I want to call it A, B, C, D, and E. Now in this case, if I run B, you'll see instead of having 0, 1, 2, 3, 4, which is the default behavior of a series, it will use your indexes and assign these values to those indexes. Now it looks like key value pair. So is there a way we can set it as key value? Yes, there is. So what we can do is, just to make it easier, you can say series and give a dictionary. I can say A is 1, I'm just going to give 3, B is 2, and C is 3. So just to keep it simple, I'm just giving C 3, and you see A, B, C, 3 items. Now what if I want to organize it in a different order? You can do that. You can just say, let's take the same object and say I want to use this, but I want to change the index or the order in which they appear to be like C comes first, then comes A, then comes D. Now you'll say, where is D? So let's say if I just say D comes after that and B comes after that, what it does is it will create a new element or new item with index D and add not a number into it. So that's what it will do. It will automatically create one for you and add it after at the particular point which you have assigned it to be. Now how do I get a particular value from the series object? I think you have guessed it by now. If I say, let's say C of I'm going to say C of 2, and it'll say not a number because that index doesn't work. So you can say C of A, and that will give 1.0 because that's what exists. Now if I go to, let's say, my old data set, which is A, I can say A of 2, that will work, that will give me 3. Or I can say I want all the items until 2. So we'll say okay 0 1 and 1 2. So you can say I want all the items minus 2. So that means from behind take the 4 or 4 5, and that's what you get 4 5 until the end of it. So minus 2 minus 1 and 0 you don't want because it's in the start of the array of the listing. So that's how you can get items from a series object. You can also do arithmetic operations. Let's say let's print a again. This is a. Now if I say a plus 5, what it will do is it will take each and every element inside the series and add 5 to it. I can do subtract, I can do, as you probably have guessed by now, multiplication, or you can do division. So all these options are available inside the series element. Now that's how we create a single dimensional. But what about multi-dimensional that I mentioned? Multi-dimensional or data frames, they contain both rows and columns, just like a table listing. So how does it look like? Let's go ahead and create one. I can say pd dot data frame. I want to create a data frame, and I want to display inside it something called as day. First column is day, and inside that I want Monday, Tuesday, Wednesday, Thursday, and Friday. So for now I'll just say working days, and inside these working days how many hours am I working. So I can just say hours. I can say I work 8 hours on Monday, 4 hours on Tuesday, Wednesday, Thursday, Friday. Now when I display this D, you'll see it displays in a table format. So this is how a data frame looks like. It kind of creates a table structure for you, and you can use it. You can always import another data set. That is another option. So if I want to import a particular data set, let's say for example I have this Excel which gives me the flights on a particular year, month, day of the week, departure time, CRS, arrival time, CRS arrival time, flight number. So it has all these different objects. Now I don't want to, how many items does it have? It has 100,000 items inside it. Now I don't want to add one at a time in here. What I've done is I've saved that file inside my Jupyter folder, and it's called flights.csv. So inside my Jupyter notebook I can just say pd.read csv. That's a built-in function available with the pandas. You can just say flights.csv. So it will load that file. I want to load it and add it to my variable flights. So if I run flights now, you'll see it will give me all the items, 100,000 rows, 17 different columns that are available, everything displayed here. It doesn't display everything, of course, because it will show ... because I have way too many items. Now what if I want to see, now there are some built-in functions that we commonly use, such as head, shape, tail, and describe. What are these? What head does is, flights.head, it will pick up the top 5 items from a particular data set. So if you see, it got me 5 items and displayed me here. Same thing, you probably have guessed, what does tail do? It will pick the last 5 items from the data set. What does shape do? Flights.shape. You have used shape before, so you probably guessed by now. Oh, it doesn't, it's not a function. If I run this, it gives me 100,000 by 17. Where have you seen this before? Right here. So shape is nothing but number of rows and columns. That's what it displays. And then there's another thing which is very important called describe function. What does that do? If you look at it, it went through each and every column and it said count number of items that each one of them has. So there's some of them which don't have 100,000, which means that there's data not available. Then there's mean. It gives you mean for all the years, months, since it's all for 2008. Saying mean is 2008. Standard deviation, since it's not moving too much from 2008, it's saying 2008, but others have standard deviation. Minimum 25% of the data set, 50%, 75%, max is this. These are different elements that are how many percentage do are close to a particular range. So these are the different items that you get when you say describe. So that's all available to you with built-in functions. There are some other functions, something called as lock and iLock. Now what does a lock and iLock do? What they do is you can get a few particular selections. For example, in this I can say flights dot lock. I want the row 0 to whatever row that I have, and I want selective columns. For example, I want arrival time, and I want, let's say, air time. Just display these. I'm gonna print this out, and here I have a, okay, let's try that again. So if you see here, it will pick and choose. With lock you can say that I want only 10 rows and these columns. So that's what lock is used for. You can actually selective pick what you're looking for. What does iLock do? So I'm going to copy this. So there's another one called as iLock. Inside iLock you don't have to give these parameters. I can say I want 0 to 10 and I want 2 to 5. What it does is it will pick the second. So instead of giving the names of the rows, you can just say I want the second, third and fourth column. So it just picks up 0, 1, 2, second, third and fourth column and displays it to me. So if you don't want to give it by name, you can also say row number and column number. So that's what iLock does. There's another functionality. I can say I want to drop some of the items. For example, I can say from flights I want to drop something that, let's say, a few rows. I want to drop 1, 2 and 3, and since it's from rows, I can say axis. I have to say axis equal to 0. What this will do is this will drop first, second and third. Let's add it to, let's say, flights drop variable. Now if I print this, you'll see that 0 and 4, where did 1, 2, 3 go? So it created a new variable and dropped some of the items that we don't want. So you can actually drop items from a particular data set and then just use that, assign it to another variable and use that for that. Similarly, if I want to drop let's say without, where's my data set here, I don't want to display, in this case, let's say departure delay. So I want to drop departure delay. I can say column equal to flights dot drop. In this I will say the thing that I want to drop is departure delay in my axis of 1. Run this. Now let's print this out. You'll see there's no departure delay in this particular table. So I've removed. So drop is used for removing columns and rows. You can pick which axis or which is rows or columns you want to do it from and assign what you want. Similarly, you can give multiple one. If you give it in an array, you can add multiple columns inside it. Next one is, how do I calculate, like we've seen by using describe, you can calculate the mean, median, everything. You can do that by just saying, oops, flights dot mean. Run it and it will say for year this is the mean, this is for month, so it will give you means for all the different columns that you have. Similarly, if you want median, you can just say that and it will give you medians for all the different columns that exist. I can also get minimum value in a particular place. Here since 2000 is common month, so it'll give me minimum values. Similarly, you probably have guessed it can, there's also function for maximum in a particular column and it'll give you maximum in a particular column. So min and max functions can be used for that. What if I want to define a function to do a particular operation on my data set? For example, I want to take my, let's go display flights again, don't want to scroll up. Inside my flights, I want to, let's say, there's a lot of work going on at the airport, and the taxi in and taxi out time is increasing because of a particular condition. So what I want to do is I want to define a function which adds, let's say, 10 minutes to the existing taxi in taxi out. So I take a variable s and I say return s plus 10. So this is my function that I've created. Now I want to apply this to my data set. The way you can do this is you can say flights, and then I want to add it to taxi in, and these two columns, what I want to do is I want to apply, that's where we use apply, a function add 10 and run it. So if you see here, it will, I had 10, 4, 5, 3, 3, it added 10 more minutes, 14, 15, 13, 13, 13. So it adds 10 more minutes to each and every column that I have. So this way you can write a different function to kind of do data manipulation inside your data set. There's two more that we're gonna go over. The first one is called as value counts, which is counting all the different values inside a particular item. For example, how many 4s appear in taxi in, how many 5s appear in taxi out, taxi in, taxi out. So how do I do value counts? For that I can say flights, I want to, let's say, count how many different types of values are there for taxi in. I can say value underscore counts. So when I run this, what it will do is it will look at, okay, 4, how many times does it appear? It appears 25,857 times. How many times 3 appears? 22,447. And it will order them by the time and how many times it appears over here. So there are 64 minutes taxi in delays, which is what happened one time, 70 one time, 51 one. There was one time taxi in took 213 minutes. Maybe there was power outage, maybe there was lightning, and then people were actually sitting inside. So these are different values that you can get from using value count. See what all different types of values exist inside and how many times they exist inside your data set. Similarly, there's something called as sort by. For example, I want to sort. Now if you see, these are not sorted in a particular order. They have 3, 4, after that 6. What if I want to sort based on, let's say, airtime? How much time does the plane spend in air? So I can do flights dot sort underscore values, sort all the values by which field, can say airtime. So this will take my data set. Now if you see, 78,681 came to the top. Why? Because that one has probably the least number of airtime, which is 12 minutes. I don't know where that flight is flying, but there was maybe it just turned around and came back to the same airport. So 22 minutes, 23 minutes. So there are different flights, and at the end there's not a numbers where value is not available. It will do based on that. I can also do based on something else. If you see 17, 19, 19, 20 up to 370. So you can do sorting your data set based using sort values function. So these are some of the common functions, and later on after matplotlib, when we do real projects, we'll probably be using most of these. Welcome back to Data Science. This is Vivian Arana, and today we are going to look at matplotlib, another library we have seen through NumPy and Pandas. We'll use those libraries here too, just to get some data and data structures and numerical operations. But in matplotlib is a library which is used for data visualization. We have seen like all numbers, all data, all text, but now we probably would want to see how to display this in graphs and bars. So data visualization means all the data we have in our data structures or data arrays or series or whatever you call it, all of them being plotted in charts like line charts, bar charts, pie charts, histograms, scatter plots. So we'll learn all those different types of charts and how to display your data in a way where you can actually kind of present it to your peers or managers or whoever, and kind of try to make them understand how, why, and how your data is important, what does it mean. So first, let's start with the first line plots. So let's go and create a new Jupyter notebook. I'm gonna say new notebook, and inside here now first let's go and import NumPy because I'll need that for creating some arrays. NumPy as np, and I'll also import mat, or for matplotlib you have to say from matplotlib I want to import from this particular library, I want to import pyplot, and I'm gonna name it or alias it as plt, so I can use that going forward. Next step, let's create an array. So I want to create an array of numbers. I don't want to give like 1 2 3 4, so I'm going to just create 1 to 19. That's what I'm going to do. X and Y, I'm going to say another one of range. So these are some of the things that we learned in the previous in NumPy tutorial, where we saw how you can use a range to give numbers from 1 to 19. In this case 20 is excluded, 5 to 100 with steps of 5. So it's pretty much the same numbers, that same amount of numbers that X has. Now I'm gonna use plt, which is my pyplot, and use the plot function inside there to plot a line plot, or a line plot. Yeah, so plt dot show, run it, and if you see I have a line plot here. A line plot is nothing but from one point, it kind of takes all the points here. So for example, if I want to see what's inside here, X, and if I want to see what's inside here, Y, so it will take one, it will put all of these in X coordinate. So X coordinate is here, Y coordinates are here, and it's going to plot 5 comma 1, then 1 comma 5, 2 comma 10, 3 comma 15 in this particular plot, and add it over here. Next thing that I can do is let's take the same example and add some more parameters to it. So I want to add a title to my chart. So I'm going to say plot dot title, let's say line plot, since it's a line plot. Next I want to say plot, so if I just let me run this, you'll see it will add a title on the top. I can also add titles to labels to X axis. I'm going to call it horizontal axis. Similarly for Y, I can say Y label is vertical axis, and in this case what happened, plt, okay, there you go, and I have my horizontal axis label, vertical axis label added here. You can also add grids to your graph by saying plt dot grid, and inside that do true. By default it's false, and you'll see it will add grids inside my chart. Next thing that I want to do is add some properties to it. Like for example, I want to give, let me create a new one so you guys have this. For example, I can add colors to my, so by default it's blue in color, the line. I can say I want red, so this way it will create red line. I can add more like line style. I can say line style is straight line right now. I can say I want dotted line, which is this, which will add a dotted line. I can say I want a dash dot line, which is more like this. I can also add a line width, so that will kind of give more width to my line. I can say 3, I can say 30, whatever you want. It will be more thick but doesn't look good. I'll say 5. So you can add all these different parameters. I can also create if I want to add more than one lines, so let's take the parameters of Y, and actually I'm going to do another point. I'm going to say Y2 and say Y, whatever the values of Y are, I'm going to divide by 2, and I want 2 lines, so I'm going to say plot this first line, and I want to plot a Y2 line. I'll say change the color to green. Instead of this, have a dotted line, say 3, and run this. So if you see, now I have 2 different lines on my graph. So this is another thing that you can do, which is pretty cool. what if I want to do two plots but in separate lines, separate graphs? So what I have to do for that is I would use something called a subplot. You can say plot dot subplot. So in particular, you can do it horizontally or vertically. So if I want to put two graphs next to each other, two plots next to each other, I'm gonna say I have one line and two plots. The first plot here, second plot here, and this is the first one that I'm drawing. And inside this, I want to use this, and let's say I'm going to use all these same properties here, but I want to create another one. Can say this is the second one, or sorry, first line, one line with two plots, and the second one is this plot. So it will, as soon as I plot it here, it will use it for this guy. Plot for this will create plot for this one. So what I mean by that is, if you see, I have the same line, two different plots next to each other, and since this is added here, I have to add it here. So this will create, so if you see what it happened here is, okay, so I guess I don't have to do this. In this case, what happened is it didn't add initially, if you saw, it didn't add horizontal vertical, so I'll have to add this here just to make sure even this guy has the title, the horizontal axis label, vertical axis label. So that's what it does. Similarly, I can change it. I can say it can be in two different lines, one horizontally, sorry, vertically, two, and one, so you can add it one below each other. So similarly, you can add multiple variables here. The next thing that I want to show you is, so this is all that is there for line plots. I'm going to go to bar plots. So for bar plots, it's more like you have key value pairs, or you have items and then values assigned to it. So I'm going to create a new parameter employee just to get some data. I have employees, Vivian, who works 5 days a week. I have an employee, John, who works 3 days a week, and I have an employee, Jane, and she works 6 days a week. So I have 3 employees. Let's look at how do I get their names. So for getting names, I'm going to call the list function, and I'm going to say employee dot keys. So since keys are these values, I'll get them. Next thing I want to say is, what are the values for these? I'm going to say list function employee dot values. So keys are these, you have probably seen in dictionary that we did before. So now once I have this, I can say plot a bar chart with names and values. When I run this, I'll have Vivian, who's working 5 days, John, who's working 3 days, and Jane, who's working 6 days here. Next, these are vertical bar charts. You can also do it horizontal, which I'll show in a little while. But if I want to add more items to it, like let's say I want to create a title for it, can say bar plot. It's similar to line plots. X label equal to employee names, plot dot y label, and y label is work days. And if I want to show grid, same thing as before, can do true, and I can say plot dot show. And in this case I have a problem, y label is not spelled properly. There you go. So my title, x label, y label, all the different parameters. If I want to make a horizontal one out of this, all I have to do is bar h and run it, and you will have a horizontal bar chart. It just all you have to do is change the parameter. Similarly, you can also give like properties to your, like color. I want to change it to red, and you can have these properties added to your bar charts. The next chart in line is scatter plot. So what are scatter plots? Scatter plots are used quite a lot in data science, where you have multiple clusters of data, and you want to kind of figure out the best way to get where the clusters are, or if you want to add multiple points in a graph and try to get the standard deviation line over it, or what is the formula to get prediction. So these are scatter plots are used quite a lot over there. So how do I create a scatter plot? So I have x coordinate. I'm gonna do np dot random for my y axis, because I want random numbers from, let's say, 1 to 100 with 19 items. Since we have x has already, we have created x with 19 items right on the top right here. So I'm going to use x same and create my y with random objects, and then I say plot dot scatter, give x and y, run it, and I'll have a scatter plot. And this is how a scatter plot looks like. Can take this and then say scatter plot. Actually I have this I can give more properties to it. For example, these dots are called marker, so I can say instead of dots I want star, so that will put stars over there. I can change the color by just using C as red, and that is color. I can give a size, can say size equal to 50, bigger. If you want to make more bigger, 100. If you want big stars, it doesn't make sense, it doesn't, kind of defeats the purpose, but there you go. So this is how you can create scatter plots with dots or with the stars inside it. Now what if I want different types of data in my scatter plot? In that case I can, let's use this again, can add it here, and then I'll create one more parameter, call it z equal to, and again same values, but again it was, since it's randomized, both the objects will have, items will have different values inside there. And I have this, and I'm gonna write it twice. Actually I'll use this one for this guy, x and y, and for this one I'll say x and z, and for marker I will use the same dot default. Color I'll give, let's try green, and size I'll give, let's say 50, and plot it. And if you see, I have multiple different types of plots based on the values that I get. Again, if since it's random numbers, every time I run this, execute this, it will kind of add points at different places. So this is how you can add multiple types, or kind of differentiate different types of scatter plots in particular in graph. So you can kind of have two data sets and try to compare them with each other using this in the same graph. Next thing is subplots, the same thing that we did above, but for this, having side by side, I can have, let me copy this data here, and inside this I can say plot dot subplot. So same kind of idea works here. I'll say I want to have one line, in one line I'll have two subplots, and the first one is this, and the second one, so one line to the second one is this. If go here, plot dot show, and there you go, I'll have one line, two plots separately, I differentiate. So depending on what the use case is, you can kind of display it as how you want it. Next thing that we're going to look at is, so that's it for scatter plots. Next thing is histograms. Histograms, they look like bar charts, but are used for, but as you know, bar charts are used for categorical values. Histograms are used for numerical values, to kind of add buckets or bins, what they call it, to differentiate the data. So if I have, let's say, a data set of 1, 2, I'll just add some values, 2, 3, 3, 4, 7, 8, 5, 9, 9, random numbers. I'm just adding, filling up this thing, and I say plot dot histogram, HIST, give x to it, and I say plot dot show. When I run it, I have a histogram displayed here. If again with any other plots, you can give it color, can say color equal to, let's say, red. I have red histogram. If you want to reduce the number of bins, so what happens is it will probably take the data and add items to it. And if you'll see, 2 and 3 has most number of appearances here in the 2 and 3 bin, because 2 is repeated 3 times here, and 3 is repeated again 3 times here. So that's what histogram does. It takes the data and puts it in bins. If I want to reduce the number of bins, I can just say bins equal to 3 and have 3, so it kind of differentiates them into 3 sets and then adds points into it depending on which. So 1, 2 and 3. So 1, how many times these things are repeated? 1, 2, 3. How many times 4, 5, 6 are repeated? 7, 8, 9 are repeated. I can kind of create 10. Doesn't make sense in this case, but since I don't have 10 numbers, 9, let's say 5. So 5 bins, 1, 2. So it will try to divide the entire data set into 5 and add the occurrences in those particular bins that it has. Again, you can add grids and all those things, but that's how you can draw histograms. Now, if I want to draw this histogram based on the previous example for flights data that I have used, if you remember in the previous video, if you're not, you can go back and check. There's flights.csv. Just make sure I save this. Python, and this is matplotlib. What we did was, okay, so first let me import pandas as pd. Once I do that, I can get flights in pd.read csv is the function, and the file that I want is flights.csv. let's see if it gets it. Okay, so I got the file. Let's look at some of the items. Head, so top 5. Now I have these items, so I want to display some of these, all the items into a histogram. So for example, I want to display airtime in histogram. What I can do is I can say plot.hist, and from flights I want to use airtime, and I can set bins. I can set color equal to, let's say, green, and I can say plot.show, do it without the bins. I have my items here, but it has too many bins here, so I'm gonna kind of try to reduce the bins to, let's say, 10, and I have a better representation of this. Since it had a lot of values, it kind of gave me that warning before, but if I do this distance, I have 10 bins where I've added depending on how much where they fit in. So this is how you can kind of take real data and add it into a histogram. Next thing that we want to see is box plots. Now box plots provides they sometimes looked as candles. What they do is they provide something called as 5 number summary. So for a number of sets, it will give you minimum value 25%, 50%, 75%, and max value for that. What do I mean there for that? So let's create some random numbers. np.random.randint, and I want 1 to 20 and 19 numbers. I'm going to copy this 3 times. Say y and z, and I'll change numbers here from 1 to 10, so 15 to 30. I can use negative numbers, minus 10 to, let's say, 15. So this will create my 3 arrays or series, and from that I'm going to say data equal to list. So I'm going to create a data object and add all these 3 items into that, x, y and z. And once I have that, I'm going to plot that inside a box plot data, and this is how a box plot looks like. This is the minimum value of the first item, the 25%, the median, the 75% and 100% maximum value. So that's how box plots look like, and that's how you can use it. You can just say plot dot show, just so it looks clean and doesn't give me all the extra items in there. So that's how, and every time I run this, you'll have different plots because I'm creating random numbers, so it will have different representation of that. And if you see, since I've used negative for the third one, it's going to start from here. So this is how a box plot looks like. Now there's something similar to box plot called as violin plot, because it looks like violin. And what you can do is you can take this data, you can say violin plot, and show. So it looks like violin. Now if you want to show medians in this, because if you see it just shows minimum and maximum and how it flows through it, you can also say show medians equal to true, and you'll see it will show the median of the value. So the reason it looks like violin is because this is where the data is more, and that's why median is moved here, whereas in this case this is where the data is more, so that's why the median is on the top. So this is a good way of representing your spread of your data items. So that's what violin plots are used for. Next one, and my favorite, is pie charts. Now who doesn't like pies, right? Now pie charts gives us distribution between different categorical values. It shows their percentages in it. If you don't know how they look like, let's create some. So I'm going to create different countries. I'm going to say USA, Germany, and I have, let's say, France, and I have another, let's say, population of these countries. I'm gonna just roughly say in millions, 300 million. I have no idea, so I'm gonna say 220 million, and France is 180 million. Or I can just make sure I don't have to put them in strings. Okay, so these are my countries and their population, and I can say plot dot pie population plot dot show. Now it will create a pie chart. This is how a pie chart looks like. So this, from the numbers, I can say this is USA, this is Germany, and this is France. Now if I want to display labels, I can say labels equal to my countries, and it will add labels around it. If I want to give percentages inside it, I can say comma auto percentage equal to percentage. The format starts with percentage, ends with percentage. Inside that, I want, after the decimal places, two numbers, f and then percentage. So this is how you can specify, and that will give you that. And you can give colors. If you don't want the colors that they decide for you, you can say, okay, I want red, green, and blue. It's pretty much very close to what they have, but it will give me red, green, and blue. Similar to this pie chart, we also have something called as donut chart, and it looks exactly same like pie. Just the difference is, when I'm creating this, I have to give a radius to my pie chart and create another placeholder, and inside this I say I have data of 1. I have colors I want is white, so I'm gonna say W since it has only one value, and radius equal to 1. So 1 radius, and this has 2 radius. So what it will do is it will create a circle with radius 2 and then radius 1 here. You can say radius 3, and you see it will be bigger. So you can kind of move around the numbers and play with it depending on what you want. So this is how a donut chart looks like, pie chart. So we looked at all the different types of chart, or how you do data visualization. Till now, before this, we did how to process numerical data, how to process data structures. Now we have learned how to use those data structures and your arrays or numerical values into charts, and kind of create a project where you can demo all these items out. So that's it for libraries, and if there's more libraries, I'm going to keep on adding to this section, but other than that, these are the 3 major libraries that we need to learn: NumPy, Pandas, and Matplotlib. I'd say probably go over them a few times, practice, and let me know if you have any questions. Hi, welcome to Data Science class. This is Vivian here, and today we will start talking about machine learning. Machine learning is one of the important part of data science, and as a data scientist, you need to understand how machine learning works. And to start with, let's see what machine learning actually is. As the definition goes, or in the simplistic form, machine learning is a process where computers, which are machines, discover how they can perform tasks without being explicitly programmed to do so. So what do you mean by explicitly programmed? So for example, if I want to add two numbers, I will write a code where I will give two numbers and say add these two numbers. If I want to run a function, I will run functions. If you want to add some logic, you'll add some logic, and whenever you get an input, you do something with that input programmatically and give an output. Now with machine learning, you don't have to do that. There's algorithms written that do it, that kind of teach the computer. It's more like you give two numbers to the machine and it will automatically add it and give it back to you as output. I mean, it's not that simple, but some of the applications for machine learning are more like traffic predictions. You give a machine data about 1 year of traffic conditions in LA, it will tell you that there is traffic or not. I mean, that doesn't need a scientist or anyone to tell you predictions in LA, but that's what it does. Similarly, face recognition, you have probably seen different photos applications which does face recognition for you. You give it multiple images and then it will kind of recognize a pattern and then tell you that this person is this is the face that belongs to a person, and do you want to tag them accordingly. Sentiment analysis, what are the customers thinking? Really good about your company or bad about your company. So that's sentiment analysis. Online fraud detection, email spam, malware filtering, virtual personal assistants like Alexa and Google, they all use machine learning behind the scene, because you can't actually write code to predict every single thing that happens, or a user is going to ask a virtual personal assistant. You need to be prepared for it. So you have to kind of teach the machine of what it is. Now, what are the different categories of machine learning? There are three basic categories and everything kind of falls under that. First one is supervised learning, second one is unsupervised learning, and reinforcement learning. Now let's look at what these mean individually. Supervised learning is more about where you have data with as it says, clearly defined results, output is provided. So in this case, what happens is you give the system a set of data which has input and output. You kind of train the system. So it says at the bottom in the image where it says you provide the inputs, it trains the machine by the inputs that you provided, and you get the outputs. What you do is, let's say you take a million rows of traffic information at a particular city and you provide it to the machine and tell them that this is the time where there's traffic and this is the time when there's no traffic. And next time when you ask the machine at 5 p.m. on next Tuesday, so you're asking on the future, what will be the traffic like? And it will look at the previous patterns and accordingly guess what it is or predict what it is. So it says makes machine learn explicitly. Your direct feedback is provided. So when you train the machine, you know how the output looks like, and check with the existing data and see if it falls in that particular category and is right or not. So when you're training the machine, you have all the inputs and the outputs. It solves classification regression problems. So in classification, it's more like discrete information. For example, it will say true or false, or it belongs to a particular category. If you give it let's say a food item, it will tell you if it's a fruit, if it's a vegetable, it's meat. So those are discrete information, so it can classify things. Regression is more like you can predict a set of items. For example, you can give input as real estate values in different zip code, or you can give medical information of different patients, and accordingly when you ask accordingly if you ask for a particular zip code, what is the price of a particular square feet apartment, you can actually predict based on the previous information that you provide. So that's what supervised learning solves for you. Next one is unsupervised learning. In this, you don't have any labeled information. You just give data to the machine and it makes sense out of it. For example, I can give a machine a bunch of data about traffic and it will make sense out of it, saying that okay, this is traffic in LA, this is traffic in DC, or it can kind of say, oh, this looks like traffic at a particular time, this is traffic at particular other time. Or you can give the machine a bunch of different products and it can tell you if those products are electronic products, if they are house products, if they are some items that you use, some for example bicycles or cars. So it can give you different information based on the data you provide. You don't have to specifically label the data that you provide. It identifies structures and patterns in the data. So it looks at all the different data that you provide and accordingly sees what is common in them. Evaluation is qualitative or indirect. So you can't actually figure out if it's doing right or wrong because you're not actually teaching the machine anything. No prediction of specific details. So as I said, there's no trained information that is provided. As and when it gets more data, it can actually kind of create clusters and tell you what the data is, and accordingly in future if you give something to it, it will classify it or it will put in a particular cluster and tell you what it is. So that's unsupervised learning. Next one is reinforcement learning. In this case, it's a reward based learning where you give an input to the machine and see what it gives you as output, and if it's something that you like, you tell the machine good job. If it's negative, if you don't like it, you give it a negative rating. So this learns based on positive and negative reinforcement is more on how the machine performs at the output and what as a user is your feedback. So you kind of give feedback to the machine and it accordingly decides in future, because it wants to get more positive feedback than negative, so it will accordingly learn based on experience. So the main goal of the machine is to maximize rewards, so it wants to get more rewards based on the inputs that it provides and the output it gives you. So those are the three different categories or classification of machine learning, and we'll look at in more detail in the next section. Welcome to data science class again, and in this class we will be looking at linear regression. Hi, I'm Vivin Arana. So let's start with linear regression. Now what will we be learning in this particular class? We will be looking at how to calculate a simple linear regression step by step. We'll perform how to do calculations using a spreadsheet. So we'll take some sample data set, which I'll just create, and then we'll see how to calculate it if we were a machine, or how does it do in the background. Next, predict on new data using a model. So we'll create a model and then try to predict the values for it. And then finally implement linear regression on a real world data set. So for this real world data set, I'm going to go to a vehicle data set from Kaggle has a vehicle data set from CarDeco. This is the URL for this. I'm going to provide this in the details below, but you can go ahead and download this data set. I've already downloaded it. It looks more or like this, which has car name, year, selling price, present price, kilometers driven, fuel type, seller type, transmission and owner. So what we will try to predict will be more on what is the price of the present price of the vehicle based on its selling price or kilometers per driven on the car. So that's what we'll try to predict in this example. We'll do this afterwards, but first we will have to understand how linear regression works. So I'm going to keep a document ready to where we will take a data set, create a data set and do it on our own. So to start with, let's start with a simple linear regression problem. So what is a simple linear regression? When we have a single input attribute and we want to use linear regression, this is called a single linear regression. Whereas in our previous case, we saw that if you want to guess the present price, predict the present price based on the selling price, that's single linear regression, because you're doing output based on one single. If there is multiple, let's say if you have multiple inputs, selling price, kilometers driven, fuel type, year, so a bunch of these options, the process for linear regression is different and simpler in the simple linear regression, whereas multiple linear regression is a little bit more complicated. We will look at an example for a simple linear regression. In this section, we are going to create a simple linear regression model from our training data, then make predictions for our training data to get an idea of how well the model learned and the relationship in the data. So with simple linear regression, we want to model our data something like, I'm going to say y equal to b0 plus b1 multiplied by x. In this case, x is our input, y is the predicted output, or y is the output that we're going to provide in the start. But what are b0 and b? So this is an equation of a line where y is the output variable we want to predict and x is the input variable we know, and b0 and b1 are coefficients that we need to estimate that move in the line in a different in the line around. It can be different values because the value of x and y will determine these values too. So technically bo is called the intercept because it determines where the line intercepts the y-axis. In machine learning we can call this the bias because it is added to offset all predictions that we make. The b1 on the other hand is called the slope because it defines the slope of the line or how x translates into y value before we add our bias. So usually let me just create a quick data set so to show you how it looks like on a graph so it makes more sense. So I'm going to give some random values 4, 5, 7, 6. That's good enough for this test. And for y values I'll say 1, 3, 3, 3 again, 4, 3 again, 4. So some random values here. Now I want to calculate, this is what I want to calculate. If I want to draw this graph or put it in a chart, I can just do insert these values into a chart, and I want to do a scatter chart, and it looks like this. So if you see x-axis has x, y-axis has y, and the line, if you see the linear regression line will be more like going from here going all the way up here. So something like this will be the best linear regression, because what you want to figure out is where is the closest that all these points intersect, and for that b0 and b1, as I said, b0 is the bias, b1 will be the slope of the particular, so b0 is the bias, b1 will be the slope of this particular line. So that's what we will be trying to figure out. The goal is to find best estimates for a coefficient which is b0 and b1 in predicting y from x. So simple regression is great because rather than having to search for values by trial and error or calculate them analytically using more advanced linear algebra, we can estimate them directly from our data. So we can start off by estimating the value of b1 as, so let's see, there's formulas for this, don't remember exactly, but I'll try to write it down. So it's sum of xi, which is xi is 0, 1, 2, 3, 4, so 1, 2, 3, 4 values of these, minus mean of x, where x is the average of all the x's together, and that so that's the first parameter, multiply by y of I minus mean of y divide by sum of xi, it's not 1, xi minus mean of x square of 2, that's the value. So there's numerator, which is this above, divide by the sum of xi mean of x squared root. So we'll try to figure out all these values from here. We can calculate bo and b1 once we have b1, bo can be calculated easily by using the formula mean of y minus b1, which we'll get it from the above formula, mean of x. Okay, so that's how we can get bo. So estimating the slope, which is b1, let's start with the top part of the equation, which is the numerator side of it. So let's see how we can get that. So first I'm gonna try to get the values for x. So let's say x, and then I'll copy all the values of x under this here, and then let's say what is mean of x. So in this case, since I want the mean of x, that will be equal to can say average all these values, and I get that. So it's 4. So I'm going to use 4 for all of them. The reason I'm writing this here is because in the next one I'm going to calculate x minus, so x of I, this particular formula here, x of I minus mean of So I'm gonna say x, I'm gonna just write it that way, x of I minus mean of x. So let's get going, equal to this minus this. So minus 3, 1 minus 4 is minus 3. Similarly, I can just drag and that thing. So I get this particular value, xi minus mean of x, for all these values here. Next, let's do for the same thing for y. I'm gonna go ahead and do this very quickly. Same thing, I want mean of y and yi minus mean of y. How did I find mean? I said equal to average, oops, do it to first, average of this entire set, get 3 is the average. So I'm going to use the same thing because I'll need it to negate here, equal to this minus this. I'm going to go ahead, pull it down. So values for that. So I have calculated this xi and yi mean. What I need to do next is I want to multiply both those values. So this xi of mean of x, yi mean of x. So I'm going to just copy this from here so that we have the reference, equal to this multiply by this. I have this 6 value here. So similarly, now I can go back here and pull this down 7 times. I'll make sure 1 2 3 4 5 6 7 1 2 3 5 6 7. The last one doesn't have a data, so that's why it's putting 0, because it's taking the next value here. So 3 multiplied by 6, and all 3 are 0, so it's going to be 0. 1 times 1, 3 times 0 is 0, and 2 times 1 is 2. So that's what I get for this thing. Now I will need the sum of the entire thing. So I say equal to, can just say sum, again, sum of all these values, and that comes to be 9. So I'm going to make it colored a little bit. So I got the numerator value here. Now what I do next is I want the bottom part of it. So I'm going to go ahead and say x minus mean of, so I need x minus mean of x. So that I already have the values. If you see here, I have those values here. So I'm going to copy these, paste it here. It's not going to show up properly. Let's say minus 3, minus 1, minus 2, 0, 1, 3, and 2. So that's my values. Now if I want square of those, one way of doing it is multiply by this again, and can just drag this, and I have the values available here. Now the bottom part is sum of the entire thing, so I'm gonna get equal to sum of this entire thing. There you go. So I have 28 as the sum. I'm gonna mark that. Now once I do that, I need to divide these two values, which is 9 divided by 28. So that I get 0.321. So that's the value of our B1 here. So that's how you calculate B1. So I'm going to say B1. That's the value of B1. I'm going to mark it with, let's say, green. Now how do I calculate B0? If you see here, this is how you get B0. So I'm going to copy that here, B0. Now to calculate B0, I have mean of y. Do I have mean of y anywhere? Right here, 3. Mean of x, 4. So this says 3 equal to 3 minus B1 is 0.32 multiplied by mean of x was 4. So my value is 1.72 for B0. Oops. B0. There you go. So that's the value of my B0. That's the value of B1. Now I have both these values. Now let's see how we can make predictions with this. And if you remember the formula here, this is how you can make predictions with this value. So you can just put here these values. Now if I want to do predictions, let's say x, and this is prediction of y. Do we have x values from before? Yes, I do. I'm going to copy and paste them here, and here I'm going to say actual y, which we have values here. I'm going to take these and put them here. So now how do I predict the value of y? Predict the value of y is equal to b0, which is this, plus b1, b0 plus b1 multiplied by x. So that's how I get the predicted y value. Now I can drag this down and I'll have predicted value of a61, which is this one. No, that doesn't, because it took the next one. So I'm going to do 0, this one too, 60. It just went to the next line since I pulled it down. Same thing, 60, 60, and 60 for this guy too. So these are my, they don't look right now because a60, which is b0, plus c56, which is this one. So this has to be again c55 for all of them. 55, c55, 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 and c55. Change this one, 55, and these are my predicted values based on the b0 and b1 that we have. Now if you want to plot a graph based on these, let's go and create a scatter graph that we did something similar to before. So if you see, it's a straight line. This is where the line crosses. Now if you want to make a line based on all three values, what I can do is I can just go ahead and say insert a scatter graph, and now you'll see here, make it a little darker so you can see. So the original values are in orange, whereas the predicted line or the regression line is right here in a straight line, and that's our predicted value. Now, so if you see here, we have this line where this orange, this point is particularly perfect, but most of them have some error. Now how do you estimate this error? We can calculate an error for our predictions called something called as root mean square error, or also called as RMSE. So RMSE looks more like, the formula is square root of sum of pi predicted index minus yi root square of 2 and divide by n. So that's the formula for this thing, where square root is square root of function, so you probably know about square roots. P is the predicted value and y is the actual value. I is the index for the specific instance that we have. N is the number of predictions that we have, which is 7 in this case, because we can calculate the error across all the predicted values. First we must calculate the difference between each model prediction and the actual y values. So to do that, let's go ahead and write them down. So we have the predicted y values here, we have y values here. Now for the error, what I need to do is equal to, I need to do is a90, so this value, or so this value minus this value. That's my that's my error in prediction. So equal to this, this minus this. So I can just pull this down, have the values out there. Let me look at them. So they look fine. So this is the prediction value. So if you see this one where the orange and the blue line are intersecting is very close to 0, but that means the prediction was perfect, whereas this one has a high wrong prediction because of course 1 and 2.04. Now square of this, so we did the first part which is pi yi. Next, now square of that is, because I have to do pi yi square of that, so equal to this multiply by this. I can just pull this down and that will give me square of the entire thing. Now sum of the value of this squared. Now if I want to get the sum of that, I can say sum of all these values, and that is my sum of the entire value. Now to do the square root, or first I have to divide by n, sum divided by n. So we have 7 values, so this is equal to this divide by n is 7. Say this is that value which is sum divided by now square root. So what you do is equal to, now there is a function square root of this value, and that's our RMSE, or something that is called as root mean squared error. So the less this is, perfect your predictions will be. So right now it's 0.66, so it's a little off, but it's pretty good for this. The best fit line that you can create for this predicting these values. Each prediction is on an average wrong by about 0.66626 units. So that's how you can calculate this RMSE. Next, now let's go to the, so this is how I mean, it's pretty simple if you try it once, but you have to do it only once at least, so you understand how linear regression works. So next thing, we'll see how easy it is to do it in Python. The reason I went through this is you have to understand how they calculate all this, or how we used to programmatically calculate it before, and now it's made easier for us using all the different libraries that are available. So if you've already downloaded the data from here, I'm going to go to my Jupyter notebook, and if you see, my file is here called as car.csv. I'm going to start a new Python 3 project. In this, so if you have gone through all the videos before, if not, you might miss out on some of the things, but what I'm going to do is I'm going to start importing pandas as PD. That's the first step. Next, I want my car data, so I'm going to say car data equal to PD dot read underscore CSV, and we've done this before. If you are missing out on something, you can go back and refer that. So I have my car data inside here. I can always look at my car data completely, or if I just want the head part, only the top 5, can look at the head 5. So you see car name, year, selling, everything is available in this particular information. Now what we are trying to predict is sometimes called as dependent variable. In our case, we want a dependent variable to be present y, which is y in this case. I can say car data, I'm going to put that inside a array of present data. So I have my y data available here. Oops, sorry, present price, and I have present price available here. Next thing I want to do is my x value. Now in this case, I'm going to say car data, and my thing that I want to use is selling price. So just simple linear regression. Now we don't want to do the entire linear regression, so there's a library available, sklearn, that's what we'll use. Inside that we have linear model, import linear regression. Hope it worked. Let's see. Perfect. Now next thing that I want also to import is for our training and testing. So what will happen is we will take these data that we have, which is, let's say, car data dot shape. If you see, I have 300 rows of data inside here. What I want to do is I want to take this 301 and kind of use 30% of the data for testing, whereas 70% in training. So when you do machine learning, what you do is, or supervised machine learning, you give maximum amount of data, as much as you want, sometimes 70%, sometimes 80%, to train your model. And once it's trained, you test it with the rest of the data, 30% or 20%, whatever is left. And so this allows the computer or the machine to understand what you're providing with label and values, and then it also allows to test based on the testing data if it predicted the right value or not, just by cross-referencing. So that's how it works. So I'm going to use for that sklearn has another item inside here, model selection. So this will do model selection for me. Import train test split. So when we give it data, it will use different models to find the best algorithm to give you predictions going forward. So that's what this is used for. Now to test it, I can say train test split. Now I'm going to tell him how much data should I use. You use my x variables, x parameters, y parameters. This is what it takes. And the third one is test size. What amount of test size do you want to use? Out of your 100% of the data, do you want to use 0.2, which is 20%, or 30% of the data for trainings, which means the rest of the data will go to testing. So this will give me 4 different items: x train, which is training data with x, that will give me x test testing data that are available. So since I said percent, it's going to give me 210 rows, 91 rows, 30%. Again, y train and y test. So it's going to divide the data into that. So I'm going to put them, it's tuple, so I'm going to say x train, x test, y. I'm going to put them in different parameters. Make sure I use the y train comma y test equal to, so these are my parameters. So it's going to put all those values inside this. Training 70% of the data, testing 30%, 70 30. Similarly, if you do 2 here, it will 80 20 80 20. That's how it will define. What am I initialize my linear regression class? So I'm going to say linear regression, initialize this. Next, once I have that, I'm going to say lr dot fit. So try to find a model which will fit this training model and training y, x train and y train. This will copy paste all the values inside that, create my linear regression model. Now I want to xy pred equal to lr dot predict values for my testing parameters in x. And let me see, I did something wrong here. Predict is the function, predict for x test. So that's what that does. Next thing, let's look at y test dot head. So if you see some parameters here, which will be my present values versus the values that I get for the testing data. I'm going to say y predicted value from, let's say, 0 to 5, the top ones. So if you see, the actual values for testing was 0.8, predicted was 0.74, 25.39, 35. So if you see, it's very close, not close enough, but it's very close to my testing data, whatever it predicted. So the 30% data that it took, it started predicting and it put in ypred. That's what I'm displaying here. And I'm testing with, I'm looking at the test data that I had just to compare how much off it was. And so if you want to kind of get the root, so this will give me a prediction information. But now if you want to see how much was the RMSE, the root mean square error, I can, from sklearn metrics, I can import mean squared error. Okay, inside that I can say mean squared error with, it needs 2 parameters, testing and my prediction. And that's what we used right in our Excel. So right here, so here you saw what we did was, we to predict, to look at the RMSE, what we did was we gave the y value was predicted value versus the predicted value versus the actual value. So that's what we need to give it to our function here, run it, and it's 0.0. So it's like perfect prediction. That's what it's saying. Why? Because I put both the same values. Okay, change this to predictor, and there you go. 21% is the RMSE of this particular prediction algorithm. Now I can do it multiple one by saying that I also want in Y, I want the, let's say, kilometers driven. So in my X, in my variable, I'm saying that predict this based on these two values. So I can just go ahead, run all these functions one more time, and now you'll see it's 40, so it's much higher. What if I just do based on kilometers driven, and it's 145, so it's growing more and more. So depending on what the variables are or what you give, you can actually get a better model out of it and predict values from this. So this is how linear regression works, and this is a class on this is a particular code on that. You can try it on your own, follow this, and this will be available in GitHub. Hi, welcome to data science class. Today we're going to learn about logistic regression. Hi, I'm Vivin Arana. So let's see what logistic regression is. We just came from linear regression. In linear regression, we could actually track a set of numbers based on an input. You can predict the output. We also saw how to kind of do it from scratch, linear regression with using equations. We're not going to do that for logistic regression. If you go to Wikipedia and look at the definition of logistic regression, it's usually used for conditions such as pass, fail, win, lose. So more of it's a logistic statistical model that in basic form uses a logistic function to model a binary dependent variable. So that's why in this case we're going to look at how do we do this in Python. We're not going to go over the math part of it. It's quite lengthy to do this, and as you saw in linear regression how we did it, but similarly if you want to go ahead, you can go through this and try to figure out how to get that, but we're going to skip that part and directly jump into Python. So for this, I got a data set where from Kaggle, which is diabetes prediction using logistic regression. It has all the information, like suppose if a person is pregnant, glucose level, their blood pressure, skin thickness, insulin, BMI, diabetes, age, outcome. So what is the outcome of that? So is it 0 or 1? So we will try to keep this as the dependent variable, and we'll play around with different independent variable. If you see, the value of this is 0 or 1, which is binary, and that's what we are trying to predict here. So I'm going to go to I'm going to download the file here. I have already downloaded it and kept it inside my project folder. If you see, it's diabetes.csv. I'm going to copy this for later. I'm going to go new Python 3 project. So I have a new project here. So I'm going to go ahead and say import pandas as PD. Next, I'm going to say, let's say diabetes variable equal to PD dot read CSV. Inside this, I'm going to add that CSV file. Once I have that, let's look at the head part of it. Let's say head. And I see all the data here, so the top 5 data that I have. So now let's play around with values. So I'm going to start with X variable, which is my independent variable. I'm going to say diabetes, my variable. I'm going to pick, let's say in this case, let's pick glucose. So depending on your glucose level, you can predict if you're diabetic or not. I'll do that. Y equal to diabetes, and I'm going to say my dependent variable is outcome. So I have that. Now that once I've said that, something that we did in our linear regression, if you've not seen it, I would probably recommend you go first see linear regression and come to logistic regression. We're going to use the same library that we used there, which is sklearn dot linear model to get a model. I'm going to import logistic regression in this one. In the previous one we did linear, and so this one is logistic. That's the difference. And I'm going to create a variable lr, or I can say log underscore r, just to have a different name from the previous project. And I need the train split. We're going to do the same thing. We are going to take the data set, we're going to train with 70% and test with 30% to find the accuracy of the model that we get from here. So what did we do last time? We did sklearn dot model selection import train test split. So once I have that, I can do same thing what I did last time. We can divide them into x. It will give you a tuple with 4 values. So I'm going to say x train, x test, y train, y test, and the function that gives me this is train test split. And inside this I need to pass, if you remember, x values, y values, and test size. Same thing I'll do. I'll give 0.3. If you want to give more or less, up to you. And then next is I have to fit that. So I say log r dot fit. I want to fit inside this particular logistic regression. I want to fit the x train and y train. So we train it. Once I do that, I'll see a small error here. You can ignore that error right now. It will not cause any problem. Y pred equal to the prediction values I'm going to get from log underscore r dot predict based on my test variables. So first I trained the model with my x train and y train. Now I'm saying give me the predicted values from my x test variables, same that we did before. So now let's look at the values of what do I have in the y test. So these were the values in the test variable. Now let's see how do they compare with our predicted values. So I'm going to say y pred 0 5, and there you go. So if you see the difference 0 0 1 0 0 0 0 1 0 0, it's exactly the same. So it looks like as compared to the top 5, it has predicted everything perfectly fine for us. So this is 100% prediction for the top 5. But how about over the entire thing? What is the error ratio? Something that we did in the previous linear regression, we used something called as RMSE, but in this case we're going to use something called as confusion matrix, which kind of gives us numbers of how much was predicted right and how much was predicted wrong. So that is another thing that is another class that exists in sklearn dot matrix import confusion matrix. Now to get that confusion, call this function matrix, and inside this I'm going to give them y test and y pred. So it's going to calculate how much was predicted right and what was predicted wrong. So in here, if you see, the value is 131, 11, 53, 36. What does this mean? The first number here on the top is the number of correct predictions for 1. So what was observed in y test and what was in y pred. So there was 131 values which reflected exactly same, which were predicted right for the y test. What is 11? This is observed as 1 but predicted as 0. So that's 11. So that is wrong prediction. 53, again this is expected 0 but predicted 1. So 53 wrong prediction. So if you see, this diagonal here is wrong prediction, where this diagonal here is the right prediction, which means 36 was observed was 0 in y test and predicted was 0. So these are the right calculations and these are the wrong calculation. Now if you want to see the percentage, what you do is you just add up the right ones and divide them by total numbers. So for example, I can do 131 plus 36, these are the right ones, divide by simple math, 131 plus 11 plus 53 plus 36. So if you see, the efficiency of this particular model is 72% or 723% or 72.3%, which means it's pretty accurate. But can we make it better? You can always try a bunch of different things, like, okay, instead of glucose, can I use blood pressure? I can try that and run through it and see if my number is 154 for this and 0 for here again 154 plus, I can actually not add zeros, just 77, efficiency 66%. So not as better as what we did with glucose. How about if I do, let's say, this one, or age? So, or what you can do is you can add bunch of different values together. I can say I want blood pressure, I want glucose. These are all different variables for having. If you have these symptoms, you know that person has a high chance of having diabetes. But if depending on how high the number is, so I'm going to use bunch of different variables and try to find out what is the percentage that I get. So I have 131 correct plus 50 for non-diabetic people, 131 plus 14 plus 36 plus 50, and that is 78%, much better than what we did before. So using more different variables from here kind of helped in this particular case. So similarly, you can mix and match and get the best value for your prediction values. So this is how we can do logistic regression. I'll have this code up in GitHub. Follow along, and if you have any questions, let me know in the comments. Welcome to data science class. Hi, I'm Vivin Arana, and today we will learn about decision tree. So we learned two different algorithms before, linear regression and logistic regression. Decision tree is another one of those algorithms, but in this case we can do both regression and classification. So in Python we have an option to do both of them using decision tree classifier and decision tree regressor. So what is decision tree? So let's look at some of the examples here. So if you look at decision tree, it's more based on a tree structure. For example, this is a data set here for Titanic, and if sex is male or female, if it's not a male, then he survived. If it's male, is the age above 9.5. If above 9.5, then died. If it's less, then depending on how many siblings or spouses they had on ship. So if it's greater than 2.5, died, or if it's no, then survived. So that's how you can probably check how a decision tree looks like. Now this decision tree, as I said, it provides both classification and regression models. So what does that mean? In linear regression, we saw that we actually get a set of values and we can give a value for prediction and it will give me a corresponding value. Whereas in logistic regression, we saw that it's more on discrete values. So you can classify a particular set of data to belonging to a particular category. So true or false, A, B, C. So it kind of classifies those values. Whereas decision tree kind of does both of them for us. So let's look at some example. What I'm going to do is I'm going to pick up data for heart diseases from UCI University, and this has all information about for a particular person whose age is this, sex is this, chest pain type is this, then there's resting blood pressure, serum cholesterol in mg. So if I want to find something, for example, what is the rest blood pressure, how is it affecting cholesterol, or how it is affecting the maximum heart rate achieved. So in that case, what is the relationship between them? Because if you see, it's a bunch of numbers from 94 to 200, whereas here it's 71 to 202 or 126 from 564. When you have a variable number, it's more comes into a regression category. Whereas if you have, for example, FBS, which is 1 true or false, or REST ECG, which comes from 0, 1, 2. So these are kind of classification which can be done using logistic regression, and we will see how we can do that using decision tree. In this case, we can start with target and we can look at different options like slope or thal. What are different values that are available for this? So I'm going to download this data set, which is available in my set. It's called heart.csv. That's what I've downloaded. I'm going to go ahead and make a new Python notebook. As usual, I'm going to import pandas as PD. Next, I'm going to get my CSV file, heart equal to pd dot read underscore CSV, and put that CSV inside there. Next, let's look at if it came properly or not. head, and I have these 5 different values. Now to start with it, I'm going to start with y as heart, and inside there I'm going to give target is my dependent variable here. My dependent variable is inside this. I'm going to use let's use resting blood pressure or cholesterol. Let's use cholesterol for this example. Run that. Next, something that we've seen before for using this data to train and test your model. So I'm going to use sklearn dot model selection. More and more of these you do, more and better practice you get. You can import train test split. So once I have that, next is, as you know, we'll get data called as x train, x test, y train, y test from this particular function, where I have to provide x, y, and test size. You probably get used to this by now. I can give the data set as 0.3, run it. Next, I want to get my algorithm, which is from sklearn dot tree import decision tree. So there's 2 of them, classifier and regressor. I'm going to use classifier. If I have spelled this name wrong, it might give me an error. So classifier, and then I can say DTC equal to classifier, initialize that. Once I have this initialized, I can fit my data set to it. DTC dot fit. Now I have training data for x and training data for y. Fit that there, and it fits the data set. Now I can get my prediction for y by saying DTC dot, if you see all of these functions are same, predict for x of test. Run this. Now it will give me the prediction data. Now I have the prediction data and the, so I can always look at my y test dot head, and I have my test data. I can check my y pred from 0 to 5, since it's a array. I have 0 1 1 0 0, so it looks like it's not that accurate as we are used to before, but I can always look from confusion matrix how much is the offset here. So I can say from sklearn dot matrix import confusion matrix. Once I have that, I can say confusion matrix can give y test and y pred to give me some data. And if you see 26 right on ones, 26 right on zeros, and these are the incorrect ones which we saw before. If you have not seen those videos, I would say go back and look at them so you can see what I'm actually doing. So next is adding all the values plus 26 plus 26, and that gives me 57%, pretty low. I can change this cholesterol to, let's try this and see if it does show any difference. So this one is 19 and 35, and this probably total is same number, so it doesn't matter. 59%. So it's got a little better, but we can make it better by using different values, is what you have seen before. I can also change from target this to rest ECG. Now if you look at the data set, rest ECG has 3 different values. So does it work for these 3? Yes, of course, it's a classification method. So I can say this, and let's use the same cholesterol from before. So now instead of giving me a 2 by 2 matrix, it will give me a 3 by 3, because now there's 3, 0, 1 and 2 options. So that's why it gives me this option. Now let's look at the error for this. 21 plus 25, these are all the correct ones. Divide by incorrect ones, which is 19 plus 0 plus 24 plus 0 plus 0 and 2, so I'm going to just say 2. And if you see 1.022, so it's much above. Maybe I did something wrong with the calculation. 21, 25, 0, 19, 0, 24 and 0, 0 and 2. Looks like the math is right, but it has a percentage of 1.02, which means it's perfectly amazing, which is a little bit fishy, but that's how you can actually look at your classification in this particular case, in a case of decision tree classifier. Next, I'm going to show you how to do this for regression. Use the same thing for regression. So I don't want to scroll up, so I'm going to just say heart.head, and I see all the data here. Next, I'm going to take my variables as for y. I'm going to take this thing, trust BPS, and trust blood BP for the particular user. X equal to heart of, let's say in this case I'm going to use, let's use Thalash, which in this case is if maximum heart rate achieved. So that's what we are comparing here. So rest BP versus maximum heart rate achieved. How is it related to each other? I'm going to copy paste some of the things because they are same. Take this and use that. Next thing, I want the same as this, but I don't want classifier. In this case, I want the regressor class. So I'm going to say regressor, and instead of using DTC, I'm going to say, to initialize this guy, I'm going to say DTR. And once I have that, I need to fit. So I'm going to say DTR dot fit my X train and Y train. Once I fit these data sets, next I'm going to see the prediction values, which is DTR dot predict X test. So based on this, predict my Y values. Now test dot head, let's look at the difference. So these are the actual values versus the predicted values. Is this 127, 140, 145, 142, very close, 138, 132, 133, 130, 122, 155. This was a little off, but that's how I can get these values. Now, if you remember from our linear regression, if you want to see the RMSE, the root mean square error, we have to get the function called as mean squared error from sk learn dot metrics import mean squared error. Let's go. Guess I spelled it wrong. If you spell it wrong, it corrects you, so you don't have to worry about that. Next, mean squared error, I'm going to take that. I'm going to say y test versus y pred. Let's see what is the percentage it gives, or the difference that it gives me. 640, pretty high, but that's how it is for these values, and that's how it's defined. So you can keep on changing different values or give more attributes to it. Instead of just this, I can also say I can give cholesterol too, and see if it makes it better. So 1768, offset increased quite a lot. So you can kind of try around with all these different values and see what is the best option that you get where the mean squared error is minimum. That's the best thing that you need to do. So that's how, using decision tree, you can do both classification and regression. And again, if you want to change this data set, go for a different one, go to Kaggle, create an account, and then you can probably here get a lot of different data sets available for you to play around with it. If you want to do classification, you can just say classification data set for machine learning, and once you do that, you'll probably find a bunch of different data sets available that are there. You can say I want to do something for decision tree. So if people have tagged their data set for decision tree, you can get those data sets from here. You can say you want notebooks, you want just data sets. You can kind of get what you want from here and play around with different data sets. So I would say go ahead and try a lot of different data sets for all linear regression, logistic regression, and decision tree practices quite a lot, which will help you get better jobs or kind of improve your knowledge on these algorithms. So if you have any questions, let me know in the chat below. If you like this video, please give us a thumbs up, and if you would like to see more videos, please support us by subscribing to our channel.